But first things first, I have a couple of guests with me today. So first of all, I have Andrew. Andrew, are you there?
Hey.
ecnerwala of Code
Hello.
Forces and Top Coder and Outcoder and etc. fame. So Andrew's going to be casting with me, and then we're also going to be doing a little bit of an exhibition match afterward, but we'll see how that goes. And then I also have Tourist and Umnik, our top two finalists. Can you guys hear me?
Yeah, sure. Hi.
Cool. How's it going?
Not so good.
Yeah, I saw the last contest. It seems like it was a pretty exciting contest. I mean, Raidbush did really well. But how did you think of those problems?
Should I reply first?
Yeah, please go first.
Yeah, sure. I don't know. A lot of constructive problems, I guess, right? Like it's kind of math problems.
Constructive, interactive, things like that. I agree.
Yeah. It's. I mean, it's fine.
Yeah.
I guess I'm just a bit frustrated with the result, right? Because like I had like all the time on the earth to solve problem G and I couldn't, and like many people had in 5 minutes.
Yeah.
So
did you?
You know.
Did you have it by the end, or was it just like you just had no
No,
idea?
I don't know. I mean, I don't really like the constraints. I think because like so it's like 1 million. So I had an n-log n solution with segment tree, and I just felt it was really on the border.
I see. I see.
And
that's pretty.
I mean,
I saw.
Yeah, I was just had.
Yeah, I guess that was maybe that's why they set it to 1 million to try and make segment trees on the make n-log n on the border. Kind of.
Probably.
It's pretty tricky. It's a fine line.
Yeah. I like problem D a lot. I saw you had a resubmit there. I was curious what happened exactly, because it seems like you had it really fast, but.
Yeah, it could be fixed by changing two characters.
Yeah, like
it's changing them actually.
Uh-huh.
I was just sorting the pairs by whatever different thing. I sorted them by value and I sorted them by position.
I see.
So sometimes I would put k minus m instead of m or something like that. I don't know. I mean, I got it quickly, and then I was just looking at the statement, looking at the solution, testing it, and I just couldn't find it.
Yeah. That's pretty right.
So I guess it was a pretty bad day for me.
Yeah.
Or maybe it will be a pretty bad day for me. Right?
Well, we'll see how this one turns out. You still have some more contests to go, so you can redeem yourself.
Yeah.
Cool. And then we also have Umnik. Hey, Umnik, can you hear me?
Hi.
How's it going? How was your contest?
Better for me, I think.
Yeah, it seems like you did pretty well. Do you know if you're going to pass H, or has that come through yet? Maybe mine is just delayed.
Yeah, it's just not very fast, but like I don't have any logarithms in. Like I have one which is not in the slowest part. So I had square root solution without any logarithms under the
interesting
square root. So well. Yeah, I enjoy the problems. I really like the
entire Final Fantasy franchise,
which was very, very easy for me for some reason. I don't know. I just somehow like wrote each number as a difference of 2, and then everything clicked. I don't know. It's just like I have a drawing of like how these numbers work, and I think I spent more time on drawing these pictures than on solving the problem itself.
Interesting.
Cool.
Yeah,
go ahead.
The problem was like bad for me. I don't know. I think that I also have like pretty good solution, but it is slow for some reason. There are like a lot of divisions and stuff like that, and it looks like Code Forces is 32-bit, and multiplication and divisions of longs are very slow. So it works fast on my computer, and most of the time it processes fastest on my computer. But now I spent much time to fit in time limit.
Yeah, the 32-bit thing is pretty funny. I've always been wondering when they are going to switch.
So it didn't matter in the end. Like Mateusz solved everything, so it didn't matter that I spent like 20 minutes on F. Well, maybe I solved the last one, but I don't think so.
Yeah. Do you think everyone who solved H did the square root n solution?
No, I don't think that there are faster solutions.
I think I have a solution using segment tree beats, but I clearly didn't finish it, so I don't really know.
Well, okay. Yeah, I think that others meant like square root solutions. And
okay. Interesting.
Cool. All right, shall I get started? We have the big event coming up. Are you guys ready? Do you feel like?
So I have some questions.
Yeah, go ahead.
How will you send the problems, and how do we should we use this bingo sync?
Yeah, so we'll send you a link to the bingo sync, and then so Taurus, Kennedy, you're gonna be red, and then Umnik, Alex will be blue, and so then we'll just use the bingo sync to click. The problems are listed on the bingo sync as well, so you guys will know, and people watching in the chat, you guys will get to see which problems they're solving as well, and then we'll have you guys streams live while we get started, but pretty much coordinate through there otherwise.
Yeah, so I think now should we reveal the problems? And I think we can give Gennady and Umnik a little time to kind of look at the scoring and start planning out their strategies.
Yeah. So yeah,
I think the best way. Yeah, I think the best way would be just to send the links to problems at the start.
Cool. Yeah. So the scoreboard is up now, and then we have the 5 problems. So spoiler alert here, we're pulling from AppCoder regular contests.
Yeah, so, but I haven't seen the rounds now, right? Oh, they're on the stream.
Yeah. So it's all up on stream, and then Andrew, can you also put the problems in the chat as well, just so that people can follow along if they want to read?
Yeah, I'll put links to the problems.
Yeah. So that'll be once we get started. But Umnik and Taurus, you guys both see the problems and see which ones we're looking after.
Can you also send me the bingo sync link?
Yep. We'll just do that in that chat.
Yep.
Cool. Yeah, and you guys can take a couple minutes to get set up. I think it's pretty funny, how we got here in the first place. I mean, so at TCO, talking about it and then having these ideas. It sounds like we've kind of all been thinking about something along these lines, just kind of making it more esports and making it more exciting for a while. But as far as actually making it happen, it's been a bit of a wild ride. I think the most memorable part for me was so that Sunday was the TCO finals, right? And we were talking about it the night before, and we were saying do you think we can get people interested? Maybe we can get 8 people or something and just do a small bracket and see if we can, get some excitement going. And then I was commentating the finals, right? I mean, you guys were in the finals, and then Andrew was going to go talk to everybody and see who all was interested. And then after the finals ended, I saw Andrew and I was like, hey, how many people are interested? And Andrew just said everyone. We ended up having every single contestant and every single problem writer at TCO just interested. And I mean, some of them couldn't make it, or Andrew ended up having to TO the tournament, right? But it was pretty cool to see that people enjoyed the tournament. I had a pretty good tournament run too. I lost to Umnik and Pyotr, both of which were pretty disappointing, but but they're both good, so I can't complain too much. But yeah, I had a lot of fun running it, so. Are you guys ready to get started? Shall we?
Whoa.
Not yet.
Where should we? Where are the links to the problems and to the bingo stuff? And
so Here, let me send the bingo link to you guys right now. I think we can send you guys. You can log in. How do I send them the password?
I think on the same Google Hangouts chat is fine, right?
Yeah, just don't show their screens.
Yeah, that's fine. Got a lot of
Scott,
messages.
by the way,
yeah, go ahead.
Can you make me moderator in chat?
Yes, I need to learn how to do that. Okay, but yeah.
/mod.
Okay, /mod. Did that work?
Not so sure.
Cool. Yeah, we have some questions in the chat. First one, what is the 3x3 grid? So let's just do a quick recap of the contest. So this round is going to be something like 20 to 30 minutes long. It's going to be pretty fast paced. We have five problems. It's a 100 pointer, 200, 300, 400, and 500. And the way the contest format works in particular is only the first person to solve this problem, to solve each problem, gets the points. So for example, if Umnik solves the 200 pointer, then Taurus won't get anything for solving the 200 pointer after. Obviously there's 1,500 points total here, which means that whoever gets 800 or more points first is going to be the winner of our contest. And I saw another question, which is pretty funny, which is why is Piotr not here? So all of us actually did a bracket. We have the link on Challenge. I think it's just challenge.com/bracket/lockout0, but Andrew, you probably have it.
There's no, yeah, I'll paste it in chat.
Okay, cool. But yeah, there were 16 of us in a bracket. We did a whole double elim competition and everything. It was super exciting. Yeah, these are our two finalists. So from winner's side, we have Taurus, and then from loser's side, we have Umnik. Yep, Andrew just linked the original bracket. And yeah, so thus far, obviously, we've been just kind of like making do with old problems and just making sure that none of us have done these problems. I mean, we've done USACO problems, here we're doing AppCoder problems, but pretty much anything that we have access to that are like good problems that we probably haven't seen before. I think in the future, there's a lot we can do with, creating our own problems and so on. And I think that the style of this contest also just kind of leads to a somewhat different format of problems. Like it's a lot more about kind of like problems that emphasize speed, problems that have like this like neat little trick, and then once you figure it out, it's a totally different world instead of kind of routine technique. Yeah, so we will be broadcasting Taurus and Umnik, so we'll get to see their screens, we'll get to see what problems they're working on. So they're going to be muted and everything, so they won't hear what we're talking about, or they won't know, what the other person's working on, but they'll at least see the scoreboard. So as soon as someone solves a problem, we'll see them come in. Like in this case, it'll be a red square if Taurus solves a problem, it'll be a blue square if Umnik solves a problem, and then we'll also get to see the live action on their screens. When will this come to Codeforces? Hopefully soon. Yeah, and exactly. So this is a head-to-head competition. It's kind of different, right, from most programming contests. And yeah, I mean, I think there's a lot of interesting ideas here with the bracket. We'd love to get you guys' opinions as we keep going. So we'll get to see the problems. We'll get to talk about the problems live. I think, Andrew, you've seen these problems before, right?
Yeah, so I've taken a look at these problems already. And I think we'll start. Chat is asking a lot about when we'll start. I think we'll start probably in about 5 minutes, just as soon as all the contestants are ready. Yep. So yeah, I've actually seen these problems. I went and solved them last night after picking them out. And I think we're in for some good competition.
Cool, sounds good. Yeah, if you guys were watching at Topcoder, the way we had it is, in that case, it was some of the problem writers, right? But we had one person who like knew all the problems or was heavily involved with the problems, and then one person who was coming in solving them from scratch. And that's kind of the same dynamic that we're going to have here. So I have not looked at these problems, so I'm going to be coming in basically just like you guys in the chat. And I'm just going to try to give my first instincts. Then Andrew will probably have to correct me and tell me all the things that I'm doing wrong. But I'm sure we'll have a good time with that too.
Yep.
Cool. All right. You guys ready to get started? Thank you.
right.
You guys want to see Umnik's hair? Here, so I
Everyone?
also have Neal with me.
So I'm Neal, and since there was a lot of posting and questions about this, yes, we are brothers.
This question comes up like every other year or something. It's the same thing.
Oh, so maybe we should update the title.
Yeah. How do I do that? I actually don't know, but that's cool. Oh.
Guys, we are talking in the chat. Please answer us.
Yep.
Right.
Yeah.
Cool. How's it looking, Tourist Umnik? About to get started? Will this contest be recorded? Yeah, we'll have the stream up. We'll save the VOD. We might put it up on YouTube as well. Yeah, so once again, if anyone is coming in, we're about to get started in the next couple of minutes. Taurus versus Umnik, the grand finals of Lockout Competition 0. We have to be, zero-based indexing. Yeah, should be pretty exciting. It'll be about 20-30 minutes long. I guess it depends how fast they solve these problems. So a question for you guys in the chat, who do you think will win? Press 1 for Taurus.
Press 2 for Umnik.
Okay, I see a lot of Taurus. Taurus for sure. Umnik's day to day.
I saw 12.
That's wild. Yeah. I mean, it's someone mentioned, but like we had a contest just this morning. Umnik did very well. So I mean, it seems like he's in good form today. I think it's honestly going to be quite close. For William. Taurus already beat Umnik. Yeah, that is true. So they played in the winner side of this bracket. So it's a double elim bracket. And so the way it works is like if you lose a single match, you're still in and you play in a separate losers bracket. And then Umnik came all the way through the losers bracket. He beat a lot of people, I guess, including myself, and then made it all the way back to the finals. So. How long is this? So the round again is going to be about 30 minutes. We're going to have an exhibition match after, a little 2v2. We might even do some more matches. You guys just saw the square flicker red, but that's what it's going to look like. So when somebody solves a problem, we'll mark that and then we'll show their current standings. Is there going to be a second set? So we're probably just going to do this as a single grand finals. I mean, there's different formats, obviously, so we can mess around with that in the future. But most of the sets up until now have been best of 3 problem sets, and this one is going to be a best of 5 bigger grand finals. So it's only going to be a single set here. Are we going to discuss the problems and solutions? For sure. Yeah. So Andrew has seen these problems, and he's gonna work on them live with us. Or we're gonna get to see them live. We're gonna get to think through them with you guys. Yeah, do you have audio? Can you hear me? Oh, I guess everyone's just muted, so I think we're fine.
Yep.
Yeah, cool.
Mm-hmm.
Aren't the contestants familiar with the problems? Yeah, it was kind of funny because we had to go through it, like, to find problems that none of us have done. Like, it took some effort to go through and find all these. I think Yusaka was a good one, just like a source of high quality problems that we haven't done, especially from the recent years. And then some of these @coder regular contests also, just because like they're not rated for us. So yeah, it took some effort to make this happen, but for sure neither of these contestants have seen these problems. Kevin wants to host a 1v1. Yeah, we might do we might do 1v1s with the chat later if we have time, but we'll see how this thing shapes up.
All right, are we good to go?
How's it looking, guys?
All right.
Tourist, Umnik, both good?
All right.
Cool. So yeah, so
Cool.
as soon as we get started, Taurus and Umnik are both gonna mute and they're gonna turn off all like the video. So we'll get to see their screens, but they won't hear anything from us. I think especially there's gonna be some pretty interesting like questions. I think even about like which problem do you work on first. Cool, we're both ready. All right, shall we get started in like 30 seconds?
All right. I'll count down. I'll count down in the chat, and we can also count down here.
Yeah, sounds good.
Sync. All right. Okay. Why don't we get started in, I guess, in like 30 seconds. I'll start counting down at like 10 seconds or something.
Chat, help us count down. Yeah, Raidwish, we'll get to see their screens, and then we'll get to talk to them after. We should have video as well.
All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, start.
All right, let's take a look. So yeah, I think first things first, it's honestly a super interesting question, like which problem do you open first, right?
Yeah, so I guess why don't we start off by saying a little bit about these problems? So these are D, E, E, and F from 2 different AtCoder regular rounds. And so the problem difficulty shouldn't be too hard. I think the hardest problem in contest took maybe around 20 minutes to solve for Yegor. So that's kind of the hardest difficulty of the problem that we're going to. And it's possible that Gennady and Umnik might solve it faster than that.
This is Taurus and Umnik, right? So we didn't expect that to be even faster.
So if I got it right, it looks like Gennady went for the 100 pointer first.
Let's take a look at Umnik and see what he's going on. Yeah, because I think there's a lot of different strategies. Personally, I'm a big fan of starting on the 300 pointer. Like, I think it gives you a lot of options. Like, let's say you solve the 300 pointer quickly, right? Then obviously you have the option of just going for the 500 pointer and then you win outright with 800. Or you can take the 100 and the 400 or kind of all these different routes. Plus you get to kind of see what they're doing. Obviously, I think the worst case is to get sniped on a problem. Like if you both work on the same problem and then they get it first, then you're even ground with them as far as the progress you've made, but you're at 0. So interesting to see that they've gone for somewhat different problems. Umnik, I think, is going for the 300, right?
That's what it looks like.
And if Gennady's going for the 100, I imagine he's actually, he's
about to finish,
already ready to code. Wow.
It's a login.
Alright, this is Gennady's password. Don't look
Password incorrect. Okay, there we go.
Alright. And that's a submission. Cool. You can see this kind of
submission.
This might be the very first problem.
Yeah. So looking at this code, I think it's going to be correct.
Yeah, he passed. So that's 100 points for Gennady, and then we're going over to this other problem. Andrew, do you want to talk a bit about this problem C?
Yeah. So problem C is kind of this 300-point problem. This is ARC 69 problem E. If any of you guys want to open the problem yourself, and this problem is it's a pretty interesting problem. The idea is that we have a bunch of piles of stones, and we're going to try and we're going to remove the stones from the piles one at a time. So you can pick the stones in any order, and each time you remove 1 stone from 1 pile. And the goal is to minimize this interesting sequence, which is after you remove each stone, you find the pile with the largest number of stones remaining, such that and you break ties by the smallest index. And your goal is to actually minimize this sequence in lexicographic order. So the rough idea is, you'd like to remove, you don't really want to remove stones from like early piles too early, because you want them to stay large so that they can be in your output sequence. So small numbered sequences you kind of want to keep, and you want to remove from like larger sequences that are closer to the end. Yeah.
I see. Yeah, so there's a lot of structure there, it seems like, and then basically you have to think through how to make the trade-offs. Or like, I think another approach is just thinking through like one by one, what does the lexicographically small sequence look like? Like, can you make a sequence that starts with A, B, C, or like 1, 2, 3? Can you make a sequence that starts with 1, 2, 4, etc.?
Yeah. And just to bring it back to the contestants, it looks like Kennedy has also started reading this 300-point problem.
Oh, that's
so
does that mean that he's solved the 200 as well, or is he just going straight for the 300 after the 100?
I think he went straight for the 300 after the 100.
Okay, wow. Yeah, he's looking through it too. So
pretty
so
interesting.
now we're gonna have a race. I mean, Umnik obviously has a bit of a head start, but if Tourist can get this 300, then Umnik is in a terrible spot because Kennedy can win with either the 400 or the 500, right? So Umnik really needs to make this work here. I mean, on the other hand, I think Tourist trying to snipe Umnik. It is what it seems like. I think if Umnik gets the 300 though, it may turn out to be a waste of time for tourists. I mean, generally you don't want to come and work on the same problem from behind. Obviously they don't know which problem each other is working on, but I think it's a good guess that Umnik is doing this one, if not. Okay.
Looks like Umnik is having some trouble submitting. He's not logged in either.
So
at least they both had this problem.
When we do this 2v2 exhibition match, we're gonna show them how to compete while logged in. It's gonna be... Well, so Umnik, I think that's a submission for the 300, right?
Yeah. And I'm looking at the results, and it looks like it's running on test 11 right now, so it looks like it might actually pass. And that's not too much of a time loss. It's actually not too much of a time loss for Tourist, because he hasn't really started this problem much, but he could have gotten a head start on the 200-point problem.
I think Umnik expects this to pass, and I think it probably will. Is Tourist still coding this one? Here's Tourist screen right here. Yeah, it looks like he is working on this one, right?
Ooh. Is that the same one?
I believe so. 16, yeah. All right, so.
All right, well, Tourist just saw that Umnik has solved it, so I guess he's now switched off this problem. Onto the 200.
That's right.
Cool. And then I guess Tourist saw that this problem is taken. Yeah. And now, from Tourist's position, getting the 200 makes a big difference because it means that he can win with I mean, I think if you're Umnik, I think it's pretty clear at this point that you want to go for the 500 point and then just have that chance to win outright. But he could always be a little bit sneaky and try to go for 200 plus 400 if he thinks that Tourist is going to try to snipe him. Right? So I think Umnik is at a spot here where he has all the optionality, and Tourist is really going to have to execute.
Let's see what Umnik is looking at.
It looks like Umnik is, as you said, looking at the 500 point problem.
I mean, I think this is definitely this is the conventional strategy, but I would love to see, as we keep doing more of these runs, I would love to see people mix it up a little bit more and go for somewhat trickier options. Because I think if you're Tourist here and you know that Umnik is going vanilla and he's gonna go for the 500, then it's a very clear decision to just try to snipe him for it immediately, and then that kind of just makes it a lot easier for him. Whereas if Umnik could sometimes go for the 200 plus 400 instead, it's a lot trickier for Tourist to know what to do.
Yeah.
I mean, if Umnik can solve this fast enough, obviously it's not going to matter. But let's see what Tourist is looking at now. I'm honestly, I mean, I'm surprised that Tourist is going for the 200. I think that if, I guess maybe Tourist expects that Umnik, maybe it's the other way around, and Tourist actually expected that Umnik would do the 200. Because 200 is also great for Umnik, since it gives him a position where either of the other two problems wins the contest. We're looking at Tourist's screen right now. I think we're about to see a submission on this 200.
Right, so it's kind of a double level thing where, Kennedy thinks that Umnik thinks that Kennedy will want to do something, and so he switches it up, and so you can kind of reach a natural equilibrium eventually.
Kind of a mix up of options. Yeah.
I think roughly at this point, Umnik wants to Umnik would rather be working on problems like Kennedy is not.
Yeah, we have a submission from Tourist on the 200. So if this comes through, then I think they'll both have a very clear decision that the 500 is all that matters for success, which is going to be disappointing because I think I'm sure that the 400 was an interesting problem, but
and it looks like Kennedy has passed it. So
right. Oh wow, okay. So it's all on this last one.
So it's all down to this last one. Andrew, can you tell us a bit about this 500 point problem?
Yeah, so this 500 point problem is actually, I would say it's like a pretty classical ACT coder math problem. So I'm not really sure whose strengths that will actually play into. But the idea is that we have, I'll explain the problem a little bit. We have n cards numbered 1 through n. And this is phrased as Snook eating the cards. But really what's going on is we take the cards and we insert them one at a time into a deck, into a double-ended cube. And each card from 1 through n, you can insert either at the front or the back. So you start off by putting them all into this deck in some order, and then you pop them back off of the deck in some order. And in each turn, you can pop either the front or the back. So there in some senses like 2 to the n possible processes that you could run. But what we actually care about is the final sequence of cards that you pop off the deck. And our goal is to find the number of sequences such that the kth element is the number 1.
So isn't it more like 2 to the 2n minus 2? But I guess there's a lot.
Yeah, it's something like 2 to the 2n. But there is a lot of overlap. Like the sequences, there are more sequences of operations than the sequences. So it's actually better in this case to think more directly about what the sequences could be.
Right. So the very first question to ask obviously is like, what makes, like, if you looked at a sequence, could you tell is it valid or not? And I want to say it's something about like longest decreasing or longest increasing not being too large, something like that. Like, because you have the 2 sides and then they come down, right? And from each side should be decreasing. Like, it should be the composition of 2 decreasing sequences.
Yeah, that's exactly right. If you think about which things you push in the front and which things you push on the back, if we ignore the stuff after, let's put the 1 aside. Let's only consider the things before the 1, because after you pop off the 1, come from both sides. You could come from both sides, and it would be a little weird. It turns out that in that case, all you have to worry about is that just adds a factor of 2 to the n minus k minus 1.
Right, and we're only looking for the position of the 1 anyway, so there is some funky stuff that happens there, but like for now, it seems like we
not really
don't worry. Yeah, we're switching over to Tor's screen to see what he's looking at. It seems like both people are coding, so I mean, I imagine they have the right idea, and it's just going to be a race from here to see who takes it.
Yeah. So the condition actually, if you ignore everything past the 1, the condition is exactly that. This sequence can be covered by 2 decreasing subsequences. And to solve this problem, you typically just use some kind of look at the greedy algorithm for kind of extracting these or finding these decreasing subsequences.
So n is up to 2000, right? So I imagine we could do some kind of quadratic DP based on the state, but how, I don't see quite how to finish it. I mean, I can see a cubic DP for sure. Quadratic is eluding me right now because you need both, like you need both of the 2 and the position that you're in, which is cubic state, obviously, right?
So it actually turns out that you don't need both of the 2. You only need the min, because after you've picked, you only need the smaller of the 2. Because the bigger of the 2, you always just have to keep taking like the next untaken number that's greater than the min.
So if a number is smaller than the min, then you prefer to take it with the min, right? It gives you more optionality. If it's bigger than the min, then you just have to take, you clearly have to take it with the larger one.
Yeah.
Interesting.
Wait, so backing up a step, we were saying that if we can get these 2 decreasing sequences down to the 1, then there's some stuff left in the deck. And so all that stuff is going to be from one side of the deck, right?
Right. So it must have occurred from like the non-1 side of the deck. And so the numbers that are in there are actually uniquely determined. And it turns out that the sequence of front and back is exactly the like possible output sequences that you could get. So that part is actually 2 to the n minus k minus 1.
Minus 1. Okay.
It's just the number of ways to pop off the remaining items in either from the front or the back every time.
Okay, so that's why we kind of just want to do a DP to compute how many ways can we get 2 decreasing like interleaved subsequences that end in 1.
Like we just care about what subsets we can create with that.
Exactly.
Yeah.
And so I think both of them, both, is this Omnix code for, this is still Omnix code for C. So there is quadratic DP, which I think is probably what Umnik and Gennady will both start going for. It looks like Gennady has already started typing, so that's pretty exciting for him. But it turns out that you can actually solve this. You can actually write this as a difference of binomial coefficients if you work it out. It turns out to look something like the Catalan number. But the n squared dp is actually pretty straightforward. The idea is that we're going to say at each step, what's the minimum element that we've used so far, and you have two options, right? You can either keep the min the same and use like the closest unused like element that's greater than the min, right? This is like if you consider the greedy decreasing sequence, you either pick to extend the sequence, or you either pick to not extend the sequence and use something that you haven't used, or you pick to extend the sequence. And it turns out that this is just a prefix, actually, of the previous dp. So the dp, say like dp of 5, dp at position 4 of 5 is like, you could either have just inserted the 5, so it's dp position 4 of 5, position 3 of 5, or it's dp position 3 of something that's less than 5. So it could be like dp position 3 of 6 or 7 or 8. And that corresponds to when you insert the 5 right there.
And just a quick recap. So we have a round here with 5 different problems. The first person to solve each problem gets all the points. You can see right now both Taurus and Umnik are at 300 points, and they're both trying to get 800 so that they'll have the majority, which means that right now that we have a standoff where both are trying to solve F just as fast as they can. We're looking, just switching over to Umnik's screen from Taurus right now. But yeah, I mean, I think it seems like both of them are getting started. It looks like Taurus has more progress than Umnik. He has a DP array ready. Going to jump back to Taurus screen right now.
No, Umnik's is actually his previous problem. So he's not started coding anything on this problem.
I see. Okay.
Yeah.
Okay, I see. So he's looking at this problem, he's reading the problem, but he hasn't written any code yet. Yeah. But yeah, I mean, it's kind of an interesting spot where at this point, the 400-point problem kind of goes away here just because both of them know that they have to get the 500.
Yeah, it completely goes away because if you get when you both have 300 points, if you get the 500, you get 800.
Yeah.
And that's enough for a win. And it doesn't matter what the 400
doesn't change that
where it goes.
Yeah, exactly. I mean, there is like, I think in this case, I mean, most likely we will see a solve, but for example, if you do a kind of like a timed version where after 30 minutes, say, whoever has the higher score wins, it could make sense. Like if you think neither of you will solve the 500, then you want to be the person that solves the 400, right? Because you want to win that, the 700 to 300 anyway. But I mean, given that these are like two of our strongest contestants, I think it makes perfect sense that the 500 is the only one that you need to be thinking about here. Yeah, I mean, Taurus is coding. I think, like, I can't imagine he would do all of this without something in mind. Whether it's like correct or whether it's going to work out is a different question, but I think he thinks he has it. So. Scoring should be 100 points for each. Yeah, I think it's honestly, like, I think it's kind of a different contest dynamic. We tried some of those too, and those were also pretty interesting. It's a lot more of a scramble because, of course, both contestants are going for the easiest problem that they can solve as soon as possible. But yeah, I think we'll get to mess around with both formats and we'll get to see how that goes.
Okay, well, it looks like Taurus is ready to run the samples.
Wow. He's passing the sample. I think this is going to be a submit from him then. Wow, this DP is so short.
Yeah,
I'm like
DP is actually.
This is just
yeah. So the DP,
right? So.
Oh, he deleted his other loop.
Yeah, like he has choose functions and he's doing a pretty straightforward quadratic DP on them. What's going on? I thought his sample was correct. Is there a problem there?
Was it?
I thought so.
Yeah, I'm not so sure. Maybe it might be a little bit off or something.
Yeah, and Umnik came in with the lead into this problem, right? He had a lot more time, or like quite a bit more time on this problem, just because he solved the 300 before Taurus was able to get both the 100 and 200. But I mean, it looks like Taurus is just moving a lot further on this one. So. take a look at Omnic screen. Yeah, I mean, still nothing going on here. I think he's still thinking, maybe working it out on paper. Where's Tourist? I mean, yeah, I wonder what's going on. Maybe I just read it wrong, but I thought he got the sample case.
Yeah, I'm actually not sure what Kennedy is working, what Kennedy's code is doing. This isn't actually quite the same DP that I had seen previously.
Okay.
But I think
maybe it's not correct then, or?
It looks like it should be correct, but I don't know. From what Kennedy is typing, it looks like there might be some off by ones or something.
I see.
Perhaps. Oh, he's actually making it into a cubic DP, so perhaps he's trying to write a slow solution to test or something.
Okay, so I guess I must have just read it wrong, and maybe he's not passing the samples then.
Yeah.
Because I thought, yeah, he ran 2,000, 1,000 for sure, but maybe he was just not quite correct.
Mm-hmm. Right.
So is this the same file that he was working in before?
Do you think he?
No, I think he made a copy. I think I saw that.
If you look at the top left, I mean, it's /e/sol.cpp. Is it just the?
I think he saved a copy of his old code, but I'm not sure. Not so sure right now.
How, you guys want to see the contestants? Yeah, we'll get to talk to both of them on video right after this contest ends. I mean, obviously both of them are in the tank right now, so we don't want to bother them. But yeah, we'll get to chat with them. We'll get to hear their strategies, all of that.
Yeah, I think Steven is saying that he made zzz-sol.cpp. So.
I see.
Yeah.
Yeah, Omnic, I mean, still thinking. It's interesting spot to be in. I mean, if Kennedy doesn't have a solution, obviously, then he's still fine. But I'm a little surprised. And it's like you're saying, Andrew, it looks like he's writing a cubic solution, which should certainly not be fast enough. So I don't know, is he just trying to test against it, or what he's thinking?
Yeah, I think he's probably trying to test against it. I can't really tell. Maybe he's trying to write this cubic solution first and then figure out how to optimize it later, which is in fact a way to write this problem. There's the natural DP actually is kind of cubic, and then you can optimize it down to quadratic using prefix sums.
Yeah, it's kind of funny that you mentioned that. I think like at the AdCoded Grand contest, which funnily enough was written by Tourist, the contest yesterday, there was a problem where it was kind of similar to that for me. Like it was the problem D, the one about the list of numbers, and it's like the sum of any k is bigger than any k minus 1. But it's like for me, yeah, I had the CP and it was like a quartic thing, but it definitely seemed like it could be optimized, so I kind of just worked from the bare bones there instead of thinking through like the kind of the, I'll say like the business logic of the problem itself.
Right,
Like,
so you got it all the way from n to the fourth down to n squared log n?
Yeah, it was n squared log n. I mean, there's a lot to do with the constant factor. I passed in like 1900 ms out of 2000, like 1920 or something. But yeah, exactly. I mean, like I was starting with the DP there, like it definitely seemed like there are partial sums and things that you can work on to speed that up.
To get to Q.
Like, it was a very like basic DP, for lack of a better word. Like it was for loops and very straightforward kind of logic inside.
Mm-hmm.
Yeah, so Tourist, it seems like still thinking through this problem. Let's take a look at Omnic and see where he's at. Yeah, I mean, haven't seen anything yet from Omnic. I mean, he's still active. I mean, he's still clicking through the problems, but I think he just doesn't see the idea quite yet. And definitely, like, you know, you don't want to code or like waste time writing a cubic solution if you don't think that you can get it to pass, or you can't optimize it. So.
Right.
It would be interesting if, you know, Kennedy jumps straight into coding like this and then has a bunch of things he has to fix, then ends up coding the cubic and then so on. And then Omnic kind of, after thinking for a long enough time, he just swoops in and gets it quickly.
If he just does it right the first time and gets it. So, yeah, I think it's still anyone's game here.
Yeah, I think it's pretty much, like, it's hard to say that Kennedy, I think this is the type of problem where the code is going to end up looking so short that, like, if you get the ideas correct, like, you can code it in a couple minutes.
Oh, I see. Okay.
Yeah.
It looked similar, but it wasn't quite right. He's
So-
testing.
The second sample.
Is that correct?
Yeah, for the second one.
Oh, he has. This is cubic though, so this is why
This
it's
is
taking so
cubic,
long.
so-
So he's running the cubic and he's making sure that his idea is correct.
It looks like it was not right.
Is that right? Wish we could see.
I saw it start with a 9.
That's actually.
Yeah. So I mean, that's even a
Yeah,
tougher
so-
spot to be in. So.
It looks like the first and second samples are both not super useful for testing. They both have They have K equals 1 and 2, which means that
Yeah,
the
it's
first
just
sample,
cubic power.
the first number has to be 1, and in the second number, it's just anything followed by a 1.
Yeah, he's getting,
and then-
he's getting the wrong number on this one, which is really tricky. I mean, like, starting with the cubic and optimizing it to quadratic is one thing, right? But if you're not even getting the right answer with your naive solution, that's worrying.
Yeah, it's going to be pretty tough.
Let's take a look again at what Omnic's doing. It doesn't seem like... Oh, he's gotten
Oh,
started.
he started.
Okay. So this is... Yeah, I mean, this is exciting. I think first things first, he's going to build a choose function table, it looks like.
Mm-hmm.
So you actually don't need the choose function table in the solution I know, so I'm actually not sure what they're doing.
Yeah, because they both have this idea, right?
Yeah, so the solutions I've seen haven't actually used choose functions. They've just used prefix sums
Well,
of
so-
the DP array.
I think the choose function makes sense because it's like okay, first things first, it's in the kth position, right? So think about the k minus
Yeah.
1 elements before 1, and you can choose any k minus 1 and it's equivalent, right? So first thing you need to do is you
Right.
need to do n choose k minus 1. And for
You actually can't choose k minus 1. I just want to stop you really quickly.
Yeah.
It's actually important because the remaining numbers have to be the smallest ones in the second sequence.
Oh. Okay, I see. So it's actually I see. It's not identical
Right.
for
Right.
selection. I see. Okay.
And
So-
so this solution actually looks pretty similar to what I think is going to be correct.
Okay.
It looks like Omnic is this. I think this is roughly the right DP. Essentially, each row of the DP is like the prefix sum of the previous row, and that looks roughly to be about what Omnic is doing. And I'm not really sure what he's. I can't really think through the off by ones just by reading his code, but it looks pretty correct.
Okay.
This j less than I equals to I thing is an important part of the solution.
Wow, I see. Yeah, so it looks like, okay, jumping back to Taurus, I mean, it looks like both of them making pretty significant progress, but we'll see how this turns out first. Chad, I want to hear you guys, what you guys think. Who thinks Taurus is going to win? Press 1 for Taurus. Press 2 for Omnic.
I think you can get into an
1.5.
interesting situation here where when you don't really know how much time the problem is going to take, you're trying to, but you know you're trying to race the other guy on it.
Yeah,
You could end up kind of miscalibrating and spending too little time on thinking,
that's a really good point.
and then just starting coding, and then you don't realize until it's a bit too late that you've missed some cases.
Honestly, I think that's what happened to
And it seems like
Taurus.
that's what happened to
Yeah.
Taurus, yeah.
It's like you expect this is going to be a problem that you have to be fast on, so your first idea, you just try it and just assume that it works without thinking through all the details, and then, I mean, then it doesn't work, and then now you're in a really tough spot. So yeah, Taurus, I think making little edits to C, but I think the one he's testing is still cubic, so he's still got a ways to go. And then let's jump
Yeah.
to see Omnic. I think Omnic, I mean,
It's
so
in the same spot.
yeah, Andrew, you were saying Omnic is building the right DP, but
It looks like he's building the right DP. I think all he has left to do is multiply by the power of 2. But maybe he's trying to think through, like, maybe he hasn't fully thought through that part of the problem yet. Or maybe he is, has other things that he was working on paper.
Makes sense. Yeah, someone asked a good question. Is there a penalty for a wrong answer? Right now, there's not, and the idea is that if you get a lot of wrong submits, that costs you enough time that it's kind of naturally a penalty. You want to get things right the first time. But
One other possibility is that one other thing is that it matters less here. But we're thinking that maybe wrong submits should be you should know when the other person submits, so that if they get it wrong, you know which problem they're working on, and that's a little information for you.
Yeah, exactly. You get to see okay, they were working on this problem. I mean, you can kind of exploit it if you just wrong submit on random problems, even though you don't have them. But yeah. I mean, a more out there idea that we've kind of talked about before is if somebody, Steven, this is what you're saying, right? If somebody submits, then regardless of whether they get it right or wrong, you just make their code public. And so it's kind of funny. Obviously, if they get it right, then this problem doesn't matter anymore, so it's fine. But if they get it wrong, then the other person kind of gets a chance to, almost like challenge phase, right? They get a chance to use the other person's code and fix it and try to figure out what's wrong. That's obviously a little more out there, but yeah. And I guess,
you'd have to. It's hard enough to read other people's code in challenge phase. It'd be much harder to actually fix it.
Yeah, we get that actually quite a bit in ICPC style contests too, because it's like you have 3 people on one computer, so you want to use your computer time as well as possible, which means that sometimes when you're debugging, other people on the team are debugging for you, and it's kind of interesting because it's like everyone has a different style, right? And it's like it definitely takes some time to understand what they're doing before you understand what they're doing wrong.
Yeah.
So it looks like they've both stopped typing and just are kind of pausing to think.
Yeah. So this contest is actually, I don't know if did we set a time limit for this contest?
No, we don't have a time limit. I mean, I expect.
So we're actually hitting the 30-minute mark.
Okay, wow.
We just hit the 30-minute mark, or in about 10 seconds. And so it looks like this problem has actually been taking them, a lot longer than I might have expected.
Yeah, and I mean, just like hypothetical, like if this were a 30-minute contest and this were the result, then Umnik would win here on the tiebreak because right now they both have 300 points, right? Umnik has 300 pointer, Torres has 100 and 200, but Umnik would win because he got to 300 points earlier. Obviously, if this actually were a 30-minute contest, then it would make more sense for them to think about the 400 if the 500 is this hard. But so just a hypothetical there.
Yeah, it's actually kind of a shame that we're not seeing the 400. Because I think there's some really good ideas, and that's one potential thing that we can think about in this format is that is there a way to encourage strategies which look at more of the problems. But I think there are a lot of strategies which could look at other problems. So
well, to be honest, I think part of it is just because this like 300 to 300 situation, right? Like in most cases, these problems will matter, but it turns out, right. Like we were saying too, like let's say Umnik gets the 200 instead. Like if he went for the 200 immediately after the 300, then Umnik can get either the 400 or 500, and Torres has to get both to win. So it's like it gets some kind of interesting.
That's a pretty. That would be a pretty interesting situation. It would have been cool to see. But in fact, we might even see it later today.
So Torres is editing a file called stupid.cpp. And I think he's just doing the exponential brute force, right?
Yeah, he's doing the 2 to the n times 2 to the n. So I'm curious whether he's doing this to try to make some more useful sample cases, because the ones in the problem are just not super helpful.
Yeah, that makes sense. I mean, I think also like...
Or if it's just to maybe check some assumption he had.
To be honest, I mean, it seems like his a lot of his core assumptions, there's something off because even his cubic solution, even his slow solution isn't working. So I think like it's a really tough spot because it's taking time off the clock, but I think this is probably
okay. So he found a small case where
5-4, and so it's pretty interesting. Okay, cool. So I think he'll go from there. Let's take a look at Umnik and see. So I mean, made some more progress since last time, I think. Andrew, what do you make of this? Does this seem like the...
So I think I know what this array D is. I think this array D is the number of paths from it's like the number of paths from 0, 0 to ij, which don't go above the diagonal. And that's actually an interesting concept to think about here. By the way, that you can actually write those as some of binomial coefficients, but you can also just compute it this way in the DP. And there's kind of an interesting view of this problem, which I'll talk a little bit about. The idea is that we're trying to move, so just to recap the solution, what we're trying to count is the number of sequences such that that can be covered in 2 decreasing sequences such that the kth element is 1. And then we'll multiply by 2 to the n to adjust for how the end of the sequence could have been like flipped and rotated, flipped because of the deck properties. And so to count the number of these sequences, we're going to casework on what the min element is at any point in time. And when you add an element, you have 2 options. You can either add the smallest element that's greater than the min, or the biggest element that's greater than the min, or you can add a new min, right? And those are your only two options. And so one way of looking at this is that, and one important thing is that you can only add something that's greater than the min if there exists something that's greater than the min, if you haven't used up everything that's greater than the min, right?
Yeah.
So if you case work on what your last element is, right? The first time your last element has to be at least, your min has to be at least 1. This after you take 2 elements, sorry, the min has to be at most n. After you take 2 elements, the min has to be at most n minus 2. After you n minus 1. After you take 3, it has to be at most n minus 2, etc. Right, etc.
Mm-hmm.
And so this actually, you can actually think of this as a path, as just a sequence of numbers that never hits the diagonal, and that goes all the way down to k. So this problem actually turns out to be roughly equivalent to the number of paths from 0, 0 to nk that don't go above the diagonal. The x equals y diagonal.
Okay. I see. And yeah, so you're saying, okay, so the C array that Umnic has is this choose function, and the D array is this thing of the paths, right? But like, it sounds like you think he doesn't need the choose function array at all.
Yeah, I don't think he will. I think if you just take a particular element of D. Oh, he's typing.
Yeah. He's erasing the loop and then typing the same thing.
He changed the
he's to a different number this time.
M to N.
Okay.
Yeah.
It's interesting to me that he has 2 variables, answer 1 and answer 2.
I'm not really sure what he's planning to do there.
Maybe he just thinks like left. I mean, they're obviously symmetric, but I don't really get it.
I'm not so sure.
Oh, maybe what it is like, it's like the different ways that you can create a sequence coming up to the one and then the ones after. But I mean, like you said, Andrew, it's really just 2 to the power of.
Yeah. So if you look at the number for ans2 he's just computed, it's m minus 1 choose I.
He's just adding all the choose.
He's just adding all the choose.
That's true. Yeah.
Exactly.
Just 2 to the power of, yeah. Okay. Well.
It's interesting that he thought of it that way.
No, I mean,
yeah,
it's right, because you have parts from the left and parts from the right.
You're picking how many come from the left.
But yeah, this sum actually is just 2 to the n.
That's pretty funny.
Look. Okay.
Okay.
Okay. So I think he pretty much has it. I think it turns out that the answer for k less than n is pretty much the same thing. I think it's dn minus 1 k minus 1 in general. So yeah, I'm looking. We should keep watching and see what he.
Wait, so you think he has this? Like, it's literally just dn minus 1 k minus 1 times 2 to the power of.
Yeah, m minus 1.
Okay, wow. So
it's like max m minus 1 0.
You're saying
he is
like
very
2 lines from done, and he just doesn't realize.
Yeah, in fact, he could delete lines and be done.
Let's check out Kennedy.
Yeah, let's see what Kennedy is up to. I think okay, so he's back on the cubic.
This is the cubic.
I mean, honestly, this still seems a ways away.
Yeah, I think he knows he's in kind of a bad spot.
Yeah, he's got soul.exe, he's got zzz soul, he's got stupid. I mean,
stupid.exe.
Yeah.
Yeah.
And so like.
He's shadowed his variable.
He knows. Yeah, this is an interesting spot. Like, yeah, so you write the slow solution, right? You come up with a case where your slow solution gives you a different answer, and then you work with that to debug because, like you guys said, the samples aren't too informative. But obviously, this takes a lot.
It looks like his code actually failed the second sample now.
The 17.2.
Yeah.
Okay.
Right there.
Yeah.
Let's check on Umnic again.
So he's starting to add something else.
Yeah, see, he's doing the choose functions here, and I guess he doesn't need to.
Yeah, so it would take me a little more time to try and understand what exactly he's trying to do. It looks like he's, switching to a different DP. It looks like, he has this. He's making this solve function.
Yeah.
Which,
Well, honestly, yeah, like I think this problem would be pretty different. I think if they had better samples, right? Like for Kennedy, potentially he would even realize before he coded it that his approach is not quite correct, and maybe Umnik, would be able to look and see that he's essentially already there, right? It's kind of funny that they they have this blank slate.
I'm actually not sure samples would help too much on this problem. The numbers are pretty opaque, and it's kind of hard to see. It kind of depends, like how good is Umnik at reading a number and recognizing that it's of the form dn minus 1 k minus 1.
Yeah,
I don't know.
That's fair. That's fair.
I probably can't recognize D.
I mean, I think at least for Taurus, right? Like, let's say you see a sample that's like 5, n equals 5, k equals 4, or something like that, right? Like that was one of the cases he was failing. That's definitely small enough that you can just do it by hand, or the sample might even tell you what the tuples are, and in that case, it could definitely save you some time.
Yeah, it's a little trickier because even if you know it's wrong, it's still not obvious which part of your DP is wrong, and so you end up having to manually compute the DP anyways, right?
Yeah.
You have to compute like every element of your DP and whether it's correct and what's the first element that's wrong.
For sure.
So it's a little tricky anyways.
Mm-hmm. Yeah. So just one more recap. We have a contest with 5 problems here. You need 800 points to win. Right now, Taurus and Umnik are both at 300, which means they have this magical 500-point problem, and that's the only thing that will make the difference in who wins. Both of them are scrambling to solve it as fast as they can. And I think that, okay. Well, he's getting case 1 wrong.
Yeah. And he's actually trying to do this choose function thing.
Okay, I was wondering if solve function would be cubic, but it looks like it's not doing it recursive, so it's just...
I think I know Umnik's problem, roughly. I think it's that Umnik is actually...
Well, now it passes that.
That's not quite. I think the correct answer is 16.
Well, the thing that's kind of funny, it's n minus 1, right? He's doing, like, it should be 16 times...
Yeah. So I think this choose m plus 1, m plus I m thing might be wrong in that it's I think Umnik hasn't really realized that you can just you can treat the tail part as part of the original sequence. So there's the tail part after the 1, right?
Yeah.
And I think one thing Umnik hasn't realized is that if you just sort that in decreasing order and then put it back on the sequence, that actually is like an entirely decreasing sequence. It is the union of 2 entire decreasing sequences. And if you observe that, then it means that it means that there's a bit less. You don't have to special case anything about the tail, except for the 2 to the power.
In this case, it seems clear why it's 16 instead of 17. I think he has some off by 1 somewhere in accessing, like.
Yeah, so he might. Yeah, I'm not really sure what this product of choose things is.
The choose function part is a little bit strange.
Yeah.
But I'm not sure. Okay, let's jump back and see what Taurus is doing, and then we can come back here later.
Looks like he is.
He's in full
right. He is.
Yeah,
in full.
Not a great look for him. I think. I think from what I can tell, it looks like he's still not sure why his solution is wrong.
So one thing you said earlier, Scott, that was interesting is the problem. The problem doesn't have great samples, but then one strategy that brings in that you could do is instead of trying to think too generally or trying to start coding right away, the first thing you could do is just make a sample, like try to solve n equals 5
by hand. Yeah.
And see what that does.
Let's see if we can see what one of this animation for this.
And so doing that gets you better samples, and that gets you.
Wait,
that looks like the right number.
That's correct, right?
That was the right number.
6, 7, 7, 7, 4, 4.
Yeah, so that gets you better samples, and maybe that will break one of your wrong assumptions about the problem.
Yeah.
The thing is that it costs more time, and in that sense, you're not thinking as generally, perhaps. So it's an interesting strategy question of whether you want to do that or not.
So yeah, I'm pretty interesting because I think Kennedy's passing this big case now, and I think he also ran it on the case that he found that fails, like the 5-4, and I think he's passing that one too. He gave 14 when he used to give 20.
But he's trying to simplify.
And now he's trying to optimize this. So yeah, okay. I think it looks like maybe just Kennedy just knew all along that. Wow, that's correct. I think we're gonna see a submit. Omnic is so close.
Oh wow.
He's submitting. Wow, that came through all of a sudden. I think he just found the one bug and then that was that.
Oh, but this is still cubic, right?
Is it?
I think he's just trying to make sure he gets TLE and not wrong answer. Like you see those three
he's
loops?
still coding, I guess.
Oh, sorry.
No,
sorry, I thought that was
these aren't nested.
They're
right?
not nested. Yeah, you're right. Okay.
Did he pass?
Andrew, you're muted.
It looks like he got wrong answer on like 3 or 4 cases, including sample 1.
Okay, so he's
one.
yeah. This
Okay.
is k = 1. Okay, and that's I think that's hilarious because he didn't even look. He knew that he was going to get that wrong. Just one more quick look at Omnic. Omnic is so close.
Yeah, Omnic is
Okay, I think yeah.
Very,
Torres
very
There's a good chance he gets this one.
He expects this to be the one. I mean, if he's only missing these n = 1, that's a great case.
yeah. I think that's it. Oh, runtime error.
Oh.
Well, that was
Okay.
unexpected. I think Kennedy will know the fix for this. Presumably, it's some array out of bounds or something.
Large.
Um,
You know how many? Is he just missing
it,
one?
it might be the n = k case or something.
Yeah, he just tried 2000 and it worked on his computer.
Yeah, he's missing just 2 cases.
Okay.
Oh wow.
And so
Oh, he got a crash from 1-1. Yeah.
Wow. He's gonna submit.
Well, he's missing 2
You said he's
cases.
missing 2, right? What about 2-2? This is just.
I don't know.
Okay, running. Is this gonna pass? Maybe 1-1 is in there.
I think
twice.
he'll miss one of the 2 cases, right?
Maybe it's in there twice.
It looks like it's.
Well,
Wow.
oh wow.
And that's how. Okay, so Torres has
And
800
congratulations.
attack.
Yeah,
Very well.
Oh, that was
played.
exciting.
Yeah.
that was down to the wire. All right.
Yeah, I honestly, Umnik is so deep in the debugging right now that I'm not sure he's going to realize for a couple minutes. But let's see. Yeah, GG's. Wow, that was very well played by Torres. I think it's like, obviously like you don't want this kind of thing to happen where your implementation is wrong, where you have to write it slow, all these things. But being able to come back from that is tough. Like it takes a lot of technique and also just like, you just have to keep a level head and debug.
I think that was not the answer.
Umnik is not quite correct on this one. But yeah, very well played by Torres. That's a good game. I wonder if he's going to do the 400 one while we wait. But he's just watching the stream. All right, I see.
He's just, all right. Hey, Kenna.
Hey,
Nice job.
Congrats.
Congratulations.
thank you.
How did you like
that was-
the problems?
Second. Yeah, sure. So,
Very nice.
yeah, I think, yeah, I mean, they were nice. I mean, at the last one, I had like 5 solutions. For incorrect
Yeah.
one.
Yeah. Do you have
Yeah,
an idea that you
you,
can try actually, Torres? People want to see you.
Yeah, sure. Yeah, they see me now, right?
I don't think we can see your video yet.
Yeah, I mean,
Oh, here we
Oh, there we
There we
go.
go. Okay.
All right, you're on stream.
Hey.
Hey there.
People are really happy to
So-
see you.
Yeah, of course. So, yeah, I was too much in a rush, I think. If I just solved this problem, just like usually on the contest, I
Right.
wouldn't for correct solutions, but I was just too much in a hurry. Yeah.
We were talking about that a lot, actually. That it's tough here because you know you have to get it faster than the other person. So if you have something that you're not sure about, sometimes you just have to go instead of taking the time to check.
Yeah, that's what I did 4 times. maybe that's not the best idea.
The k equals 1
Sometimes-
case is interesting because you were actually failing 2 cases. I don't know if you realized, but somehow the n equals 1 case
Yeah,
is 1.
2 cases n equal to 1.
Yeah.
Yeah, must be a duplicate case, right?
Did you get to
Yeah,
look
it's
at the 400 at all, or did you just go straight?
Yeah, I
guess
did.
you were the
So we
second
can
one.
save it. We can save it for the next contest.
Yeah, sorry, Andrew, I interrupted you.
Yeah, I was saying that those cases actually took a long time to run, so I don't know if it was some Stack Overflow or something that that happened from there.
What do you mean?
I don't know if
Yeah. Oh no, I just had some kind of. I mean, if n
Right.
equals 1, I was just I don't
out
know
of bounds.
insertion. I think. Yeah.
Right. Yeah, there's actually a very clean solution, and I guess we can try and get Omnic's attention.
Well, let's see.
It'd be good to have.
What's going on in his screen.
He's on his third solution as well. So Omnic is. It looks like Omnic is in a similar place to you. Omnic actually has. Omnic's code is actually he has the right thing. He just is missing. Like he could finish with like a single line of change to his code, and like a lot of deletion. But it looks like he's still debugging.
Yeah, I think that. I mean, in the end, I just decided that I just don't want to rush. I thought that.
Right.
I mean, I felt like losing anyway because I was too bad. I guess the bad streak of today continues. So I just was like, yeah, something like that. So.
Right.
Yeah, and then
Yeah.
I just became calm, and then I managed to debug it only with a stupid solution. But anyway.
Right. Do you wanna actually talk through your solution a little bit, and kind of explain what you were thinking and what kinds of things you like? What slow solutions did you implement?
Yeah, sure. So we can take a look at my screen, I guess. Just a second then.
I think it's funny that Omnic still hasn't noticed.
Yeah.
He's just really in the zone.
I mean,
Yeah,
I
exactly.
think
Yeah.
in some sense it makes sense, right?
Yeah.
Like if you look and you find out that you lost, then there's nothing to look for anyway.
Yeah.
So you should
Yeah,
just try
exactly.
to solve
I mean,
that.
The thing is, I think that we need some kind of notifications.
Yeah,
Because,
we should do push notifications somehow on the saw.
Yeah, sure.
Someone in the chat is out there. They have a plan.
I think
for this.
Omnic has noticed. I think Omnic has noticed.
Okay.
Yeah.
Yeah.
At some point, I was thinking that maybe Omnic already solved it, and you're just trolling me.
No.
No?
Omnic was very close.
Omnic was very, very close. If anything, it seemed like he just had to remove some logic from his solution to pass.
Yeah, Omnic. Do you want to hop on the call?
So yeah, here's my solution. Yeah, basically, I don't know. So if we have a 1 at position K, so the numbers before this position must have the longest ingredient subsequence less than 3. Or,
Exactly. Two.
Yeah. I mean, no, it could be 1, I guess.
It could be one. Right.
It could be 1. But anyway, so it should. So the sequence should be divisible into 2 decreasing sequences, like separated.
Right.
And then IJ is how many ways there are to make a permutation of numbers from 1 to I. Well, yeah, probably from 0 to I minus 1, so that the smallest possible end of a sequence of length 2 is J. Okay, of an increasing sequence of length 2. So I want to maintain, the smallest number such that there exists a smaller number before. Yeah.
Right.
Yeah.
Right.
Then and then I like try the next number. There are 3 cases. If it's the smallest number, then 1 case. It's the first one. Yeah, it's this one. Then if otherwise the third case is we form the sequence of length 3, then we lose. But if it's length 2, then
Oh, hang on a second. We're getting a bunch of echoing. I think it might be because Omnic has the stream open. Could you mute the stream?
Yeah. So sorry about that.
Okay,
Yeah, sure.
this is better. Yeah, sounds better.
Whatever. I think that my solution is not very. In any case, I was not prepared to explain it. I think that there should be some approach.
Yeah. So there actually is a linear time approach.
Oh, cool.
It turns out that the answer is the number of paths from 0, 0 to n-1 k - 1, which don't go above the diagonal.
Yeah, there's still a lot of echo on the stream actually, but I'm not sure 100% why. Anyway, let's see. Nick, how are you feeling? How was all that? You were so close.
I don't think so. No, I don't know. Like,
So you were looking, the array D that you have is the right array. I think that you had some, like you were adding the choose functions where it's actually just 2 to the power of m minus 1, for example, or things like that.
Yeah, I understand that when I wrote, but like it should also work, right?
Right. It turns out that ans1 always equals to d n - 1 k - 1 in your code.
Okay.
So it's just d n minus 1 k minus 1 times 2 to the power of n minus k minus 1. So you were like so close there. Yeah.
Yeah, I guess I'm not that familiar with like counting the sequences. I mean, there were like a problem in snark news something. Just calculate the number of sequences like with no increasing subsequences of length 3 and more, and I spent like 20 minutes, and then I proved that it's Catalan number. Looks like everyone else just knows that fact, and okay, cool. So
I didn't know that.
Yeah.
Great.
Do you have video that you can share that people want to see you?
Why? Yeah, I can, I guess. So you don't need my screen. Yeah, I can turn on the camera.
Here we go. There's Nick with the cyan hair and everything. Cool. Yeah, all right. So don't say anywhere. We're gonna have a 2v2 exhibition match. Taurus and Umnik are gonna be playing against ecnerwala and Andrew and I, and Neal's gonna commentate for the two of us. So I'm gonna disappear and go into the tank with Andrew, and we're gonna have a little 2v2 exhibition match after that. Should we take a couple minutes and just take a quick breather, and then we can get started again?
So can we like get some time, like 5 minutes? To
Yeah.
some
We're
water.
gonna get started in like 5 minutes. Cool. All right.
Yeah.
All right. Cool. Stick around, guys. We'll be right back.
Hey everyone, we're back. So we are about to have a 2v2 between Taurus and Umnik as a team, and ecnerwala and Scott Wu as a team. And this is going to be pretty similar to the last one, where this time instead of 5 problems, we're going to have 9 problems. And it's going to be from a few @code irregular contests as well. And you can see the scoring distribution up here on the right side. So we actually have 3 100 pointers this time, 3 200 pointers, and then 2 300s, and then 1 400. And so if you add that all up, the point total is 1900. So first to 1000 or higher will win. Okay, and so this will be interesting because we'll kind of get to see, like, back and forth. We'll see each person's screens. We have 4 screens up, and we'll kind of go back and forth, see what their strategy is, see what they're working on, and this will be exciting. Just kind of clash of minds. Right, let me check one thing. Okay, we're about to get started right here. Who do you guys think will win? Press 1 for Taurus and Umnik, and press 2 for ecnerwala and Scott Wu. All right, it seems pretty one favored. But I think this format is pretty interesting because you could just swoop in and get some of the bigger point problems and then take a big lead. So, I mean, as we saw, the last round, Taurus versus Umnik was super close. So it really could go either way. All right, I think we're about to get started here. Okay, I will post links to the
Hey.
problems in the chat so people can start taking a look. Okay, everyone's just setting up their folders and so on. Okay. Okay. We're about to start in 20 seconds. All right. 5, 4, 3, 2, 1, go. Okay, let's take a look at what they're looking at. So it looks like Scott has opened the regular 72C, and this is one of the easiest ones, 100 points. Meanwhile, Kennedy is taking, which one is this? This is actually the same problem. So this is exciting. They're both going for this first 100-point problem, and we'll see who can get it first. Just to talk about the problem a little bit. So right, so you're given a sequence of numbers. The numbers can be between -1 billion and 1 billion. And every time you can select one of the numbers and increment it or decrement it by 1. And what you want to do is, if you take the sums of the first I terms from each I from 1 to n, you want those to be alternating positive and negative and so on. And so if you look at that sample input 2 right here, this one doesn't require any steps because you've already got it alternating. So for example, the sums are 3, -3, and so on. So you just want positive, negative, and so on. Or alternately, you can do negative, positive, and so on. And so basically, you have two options there. And the way you solve this is you can think about when you increment or decrement a number, you're trying to get. So let's say, for example, we want to do positive, negative, alternating back and forth. Then when you increment a number, let's go from left to right. You increment a number to try to make that sum positive. You can go anywhere from the sum being up to +1 or higher. But it turns out you actually only want to go up to +1 because that basically lets you have the most freedom in the future. If you go further, you might actually break some negative sums that you want in the future. And so this takes a bit of thinking, but you can get through it, and then it could be a pretty quick solve. It looks like actually Genany has switched over to just looking around a bit at the other problems. This is kind of an interesting situation because you basically need to get first solves on a lot of problems, and it actually may make sense to look around a bit and see what you might be strong at, what you might be able to do really quickly. So Genany has jumped right into coding round 71 problem C. That's another 100-pointer. This one is, I think, actually probably the easiest one out of the contest. And so I think that's a good first one to do. Let's jump over to Andrew. So Andrew's actually pulled out a much harder problem. If I'm correct, this looks like, I think this is 72D. So this is one of the 200 pointers. And so here, for this problem, I'll talk about it a bit. Yeah, so in this problem, Alice and Brown are playing a game. I'll put a link to it in the chat. So Alice and Brown are playing a game. There are two piles. The first pile contains X stones and the second one contains Y stones. And they each take turns performing one operation where at each step you can pick a number I that's an integer, a positive integer, so at least one, and then you take two I stones from one of the piles, then you throw away I of them and put the remaining I in the other pile. So you can choose any integer I you want as long as you have enough stones in your first pile to do this. And then whoever is unable to take a turn loses the game. So basically you're just given two numbers, X and Y, and these are the sizes of the piles. And you want to know who's going to win the game, assuming they both play optimally. And actually in this problem, X and Y are very large, so they can be between 0 and 10 to the 18th. So it looks like, if you, at first glance, if you look at Andrew's screen, he's writing a kind of a loop up to 200, and it doesn't seem like it makes too much sense. But actually what he's doing makes a lot of sense, because he's not going to use this code to solve the problem. He's just trying to brute force the small cases with a slow program and just look for a pattern. And it turns out for this problem, if you actually go through the different cases of the problem, you'll notice a pretty simple pattern in that. Let's take a look. Yeah, so everyone is kind of jumping around back and forth on the problems. It looks like Andrew did get that 200 pointer. So Scott and Andrew are on the lead now with 300 points. And Gennady and Umnik have 100 points right now. So let's see what they're looking at. Okay, so Gennady is going for another one of the 200 pointers. Okay, meanwhile, Scott has actually pulled up one of the 300 pointers. So this will be interesting when they, start getting some more points in. Well, it'll be clear, what route they need to take to get to that 1,000 point cutoff. Right now they're just kind of trying to knock out as many points as quickly as they can. Basically the goal is to look for quick wins you can get. Okay, so Gennady just finished that other 200 pointers. So we have a tie right now, 300 points each. I'm curious actually how their teamwork is going. So both teams actually have a phone call set up between each other, so they can just talk to each other, one-on-one privately, and presumably they're, taking some time to strategize it out and think about, which ones, how should we split this up, who should go for what, and so on. So this is interesting because it looks like on this code on the right, Umnik was actually going for the same question that Andrew got, the Alice and Brown game, and looks like they got sniped on that one. Andrew just swooped in and took it. So Umnik has now switched over to, I believe this is actually the same problem that Scott is looking at. Yeah, so Scott is also coding this problem. So Scott is actually already coding the problem that that Umnik is thinking through right now. And then meanwhile, Gennady, oh, we have another submission, okay? Okay, so it looks like Gennady had a wrong submit, but then fixed his bug. And so Gennady and Umnik are now at 400 points. Okay, so now we're kind of at the stage where we're mainly at the, the harder problems in this contest. And so now you kind of need to strategize about what do you go for, what do you try to get to in order to get that 1,000 points. And so for Gennady and Umnik, they need 600 points. So there's two ways they could do that, right? They could get the 400 and the 200, or they could try to knock out both 300s, or if they really want to be superstars, they could just get 1,100 points total with a 300 and a 400. So let's see what they're actually trying to do. Okay, so Gennady is looking at one of the 300s, the 70D, top center. In the meantime, Scott is still going for that 72E bottom right 300 pointer, which is the same one that Umnik is going for. So it looks like Gennady and Umnik have kind of talked together, and they're going for top center and bottom right, and that'll get them 600 points in the win. So it'll be pretty exciting here who gets that bottom right problem. Okay, Kevin, you were asking about $70D. Okay, yeah, $70D is called no need, and what's happening is you have n cards. Each card has a positive integer on it. So basically AI are the cards, and then n is up to 5,000. And you call a subset of the cards good when the sum of the numbers written on the cards is k or greater. So good is greater than or equal to k. And then for each card I, we'll call card I unnecessary if you take every good subset that contains card I, and for all of those subsets, removing card I still keeps the subset good. And in that case, it's unnecessary. If there's any subset where it's good, but if you removed card I, it would be not good, then card I is necessary. So we just need to compute the number of unnecessary cards out of these n cards. And the key constraints are that n is up to 5,000, and actually k itself is also up to 5,000. So the only sums you roughly care about are around 5,000. And so you want to get something quadratic here. And so there's a few ways to do this. There's kind of an immediate cubic solution where for each card, let's throw it away. And then what we actually want to do is we want to find if there's a subset without card I that has a sum between k minus AI and k minus 1. Because if we have a sum in that range, then by adding AI, we get to a good subset, right? But by taking back AI, we get to a bad subset. So then I is a necessary card. And so we're just looking for anything in that range, k minus AI to k minus 1, excluding the element I itself. And hang on, who was looking at them? Yeah, it was getting okay. And so the cubic is just to iterate over I, and then do a knapsack where we take the subset sums of every other element one by one. And so that's pretty easy, kind of a standard knapsack. But cubic is too big on this problem, right? So you need to find a way to speed it up. And there are a few ways. One easy way is to use bit sets. which is pretty funny. But I just heard Scott yell. Oh, it looks like they just knocked out 700 points back to back. Wow, that was quick. Okay, now I know why I heard Scott yell. Hey, congrats, guys. Did you actually solve those last two just back to back? Oh, wait, they can't hear me.
What?
Hey, congrats.
Should we solve another?
Can you hear me?
Okay. We can solve another. All right, I'm gonna hang up. See you.
It looks like they want to go solve another one.
Oh, man. Oh.
Congrats.
Oh.
Oh man. What a slaughter fest.
Did you guys just finish those around the same time?
Yeah,
I saw them
exactly
just
the same
click
time.
in.
We
Yeah.
both submitted it at the same time.
Nice.
GG's.
Yeah.
Right,
Oh man.
Let me finish explaining. I was explaining one problem. So this problem, 70D, right? So you need to do better than cubic. There are a few ways to do this. One way is you can realize that the unnecessary condition is actually binary searchable. So you can do that and you can improve to n squared log n. The other way you can improve it is you can compute the knapsack subset sums on all of the prefixes and then all of the suffixes. And if you do that, then you can check much faster for any given element, whether you have a sum in the range. And that gets you quadratic. The one thing that does not work is just to do n cube optimized with bit sets, because of the 5,000, that's actually still too big. So that will time out. Okay, do we have everyone back?
Good job, guys.
Good game, guys. So what was your strategy for in this contest?
Oh, we didn't have any.
Okay. Were you trying to mostly go in order? Is that?
So how did it turn out? Was there overlap in which problems that we did, or how did that?
There actually wasn't too much overlap. You guys kind of knocked out these problems.
Yeah, so
the main thing was you and Omnic both went for this bottom right problem. Yeah, but you started coding before he did, and so
like, did we open it at the same time?
You worked on it earlier.
Okay.
He finished something else and then went there.
Because I did.
So that was kind of the
straight there. Yeah.
Yeah, it was kind of a point where you guys needed the 700, and
Yeah.
they needed just 600, and so they were working on
they were trying to
the
get
top
both 300s.
top center and bottom right, both
I see.
300s, and if they deny you this one, so the bottom right was like the key problem, right? Because it was kind of the one you were working on at the same time.
Yeah. That makes sense. Yeah, we're in a really tough spot if we don't get that, and then Kennedy is presumably doing the other 300 stuff.
Yeah, it's interesting.
Right,
I wonder
because-
if they maybe should have gone for the 400, because if they get that, then you guys have to get everything else.
Yeah, well, the other thing is, I mean, even the 200 is valuable there because it means they can win either with the 400 or the 300s. Maybe you don't do that first, but like, I think all four problems you can make a case for, at least, and like
Yeah.
it definitely matters. which
Yeah, so
ones,
I think strategically it got the most interesting after these kind of 5 left problems.
Yeah.
The smaller values
Right.
filled up. Yeah.
Yeah.
Yeah, I guess I didn't really realize that if they got both 300, that would lock us out.
Yeah, I
Yeah.
mean, we set the strategy from the start. Like, basically, like, we knew that we had to get at least 2 of the hard problems. The 300, there's 3, right? 300, 300, 400. We knew we had to get at least 2 of them because we weren't going to win on just, like, pure speed on the easy problems, I think. And so we just set this plan at the beginning of, we're going to do this 100, 200, 300, 400. And
Oh, really? Okay.
Yeah, and I guess we got pretty lucky that some of the early ones, like, were just, like, we kind of didn't collide, which is what we want. Andrew, I think the 400 was probably, it sounds like it was good for you. 'Cause you were pretty happy
What?
when you found out what the
Yeah.
400 was about, you were pretty happy.
Yeah, I read the 400 and it was it's a problem that I like. It's a problem format that I think I understand pretty well. It's like a pretty classical convexity trick. Like
Yeah.
it's like you're trying to maintain this DP, and this DP is actually like a convex, like a polyline, a convex polyline. If you view it as a function of like x or something, and so you just maintain like a priority queue of the inflection points. And I've like, I don't know, I've written this like a billion times.
Oh, I see. Yeah, I thought that one was interesting because like there's a pretty straightforward cubic DP, and then it kind of feels like you need to come up with something crazy to maybe like a greedy even to get the n log n, but actually you just optimize that DP with the data structure, and you have to notice a few things about how it looks. Yeah.
Yeah, you use a lot of data about that it's convex, and there's this trick that I guess I picked it up from like DYH, but this was on a code forces problem maybe a couple months ago, and like the trick is that you maintain like you want to maintain this list of inflection points. You need to support like two operations. You need to support like take this curve and shift it left and shift it right, and like take the max of this. And that's easiest if you maintain like the point where it's at slope 0.
Yeah.
And another thing is you need to add an absolute value function to it. And so that like could shift
on one side.
Yeah, exactly.
Yeah.
So you might have to like rebalance it a little bit, but that's fine. And then that's how
you only have to rebalance by 1 because it's +1 and only
right,
-1.
because it's an absolute value. Yeah.
How close were you guys on the 2 300s? Like how close were you guys to solving?
Oh, Gennady, you're muted.
Yeah. Hey. So yeah, I think that the way it went was that for bottom center, 72D.
Yeah.
Yeah, I guess he was about to submit when you got it.
Oh, okay.
Oh wow! Did I manage to actually snipe that out?
Yeah, I think so. And then he went.
Yeah, and it actually we didn't like. It's not good for me to submit text and not file, and you send the links to the old interface, so I wasn't able to submit file. So maybe I could solve the bottom middle faster. I don't know.
Wow. I didn't realize.
Not sure.
That was unfortunate.
Nick. I'm looking at our code, and it actually looks for the bottom center, and it actually looks almost the same. We both like just run the n cube dp n squared brute force, and then looked at the answer, and then
the Stones game.
Yeah.
Okay.
Yeah, our code is pretty similar. It's pretty funny.
Cool.
Yeah.
What about the bottom right? Was that?
Yeah, the bottom right is what Dominic went for next.
Yeah.
And I guess he was not close yet, but yeah, actually when we got the first 3 problems, I guess our plan was to get both 300s. I was working on 70D, and I was close to that.
Yeah.
Yeah. Oh, what was the solution you had in mind for the 70D, the middle center?
Yeah, 70D. Yeah, I still have to debug. Maybe something is wrong, but in general, I need to find if there is a for each thing. I don't know what's that. For each number, I need to find if there's a subset of the other numbers.
Yeah.
With total between k minus this number and
k minus 1.
Right.
Yeah.
Yeah. Right. So what I was doing is just doing the DP, counting number of ways, number of subsets, modulo some number.
Oh, I see. And then you.
Yeah. And then I can add number and I can subtract elements, right? If I subtract elements, then it's n square. Yeah, and then I add it back. That's it. I even think that I need to fix just one. Just one.
That one has actually a few different solutions. Another thing you can do is the condition is actually binary searchable. So if a bigger number is unnecessary, then a smaller number is also unnecessary. So that can get you n squared log n. And then another thing you can do is do just the knapsack for which sums are possible on the prefixes and suffixes. And then so you can combine the left prefix with the right suffix to see if you can get a sum without this number. Yeah. So a few different ways. Yeah.
Obviously something like that, but sure.
Yeah, I think we got pretty lucky because that 372E was like the ideal problem for me, and I think the 400 works quite well for Andrew. Also, just like
that was very quick
to get our strategy without hiccups is pretty lucky. Like we planned for these 4 problems specifically, we just pick randomly, essentially, out of the 100s and 200s, which ones we
Anyway,
want to do.
At least you had some strategy.
But yeah, I like the 300 problem all along.
If I'm like, we're a little faster on the E, then our strategy would have just completely fallen apart, right?
Anyway, I mean, so after that you could just solve. Yeah, so you had to compete on 71E, right?
Well,
Anyway.
we still wouldn't win with that, right? If we get 100, 200, 200, 400. I mean, if we lost on 72D, it would have also been interesting.
Oh, okay, I see. You actually need one.
So it was actually really important that we got the 300. And I didn't realize it came down that close to the wire while competing.
I think also, like, it's an interesting question if we actually lost the 72D, what we would do. I would probably still do the 72E, but like Andrew, maybe you would do the other 200 or something.
Yeah,
we would be in a tough spot there because you guys would obviously know.
Oh, because then you would want to get the whole right side.
Yeah, the whole.
That's what you have to do.
Pretty much.
Yeah. Yeah.
Yeah. So basically, there were two problems that were working at the same time, and you guys got both of those, and that was pretty critical.
I mean, it made the 500 points is pretty much all the difference between what we have. So.
Yeah. So if you guys want, we can run another round.
What do you guys think?
I don't know. Thanks.
Chad, what do you think? Do you want to see another one of these matches?
I think Kevin wanted to do one.
Kevin wants to compete?
Yeah, he said that earlier. I feel a while ago.
So there's a lot of yeses.
I see some no.
Should we do another 2v2? I don't know. I'm happy with this. I think a 1-0 record of Team USA over Team Taurus and Umnik, I feel pretty good about. So maybe we can do 1v1s or something else.
Personally, it's pretty hard to communicate, I think, when doing teams, and especially when doing teams online.
Yeah.
Yeah. I guess if you have some kind of determined strategy, then it's better for you.
Yeah. Look, so that was like the 5 minutes before the contest. So Andrew and I were on a phone call separate from this like stream, and that was basically what we talked about. Like, let's do this problem, and then I mean, I think we got lucky enough that strategy worked out. I think it's pretty uncommon that you get all the ones that you plan to get. Usually, it messes up somehow, but.
Yeah, I mean, I think we were within like seconds or minutes from multiple problems. So from multiple problems tonight. So it was very fortunate.
All right. What should the next contest be?
Do we want to bring Ksun in? So I'm seeing a request for Turst and me. I'm seeing a request for Ksun and Radawush, but I don't know where. I'm not sure we can find him.
Andrew, I think Taurus and you is saying you and Taurus should team.
Oh, should team.
Yeah.
Kevin and Neal, that could be fun. Well, we can.
Oh, is that Nick's suggestion? Is Kevin still here?
Taurus alone versus the whole good forces. It sounds very bad.
Kevin, say something if you're here.
How did it set up?
Yeah.
Kevin's here.
Yeah. Are we gonna make that work? We have to call him in and everything. We can do another 2v2 maybe. It seems like
we're gonna run out of problems.
Yeah. Now we have to go check which problems Kevin's done and hasn't done. It's gonna like kill another 50% of our pool. But I'm down for more. We can. I don't know. Any other formats we want to try? We can do one where each problem is just 1 point. I think that'll be a little bit different. Kind of make a bit of a scramble. Like we
right.
Super beginning.
We can do this strategy. Yeah, we couldn't do the strategy. I agree. Yeah. But.
Yeah. So I think there are like 2 more ad coders. There are like 4 more ad coders that we haven't done. Maybe 5.
Okay.
Actually, why is this not showing?
I mean, we can do another 2v2, same teams, if people are interested. We can switch up the teams a little bit.
We can toss in some harder problems if we wanted to. I don't know.
Maybe you didn't think these problems were hard enough? 400 was too easy for you?
Andrew's always complaining
I'm
that
shocked you
problems are too
solved
easy.
problems so quickly. I thought we said this problem was going to be really hard. Like, there's a reason this one's 400 and nothing else is.
Yeah, I mean, we looked at the rating and it didn't seem that easy, but...
Oh, Nick has a pretty funny suggestion, which is you try to play tic-tac-toe.
The center one is too important, though.
Yeah, the center one, everybody just goes for that one at the start, and then you're kind of...
Like, all four
if
people
you don't get it,
center
it's
one.
kind of just game.
I think the center one should be the hardest one.
Yeah.
And then
Exactly.
all 4 people go for the center at the start of the contest.
This is too much for me. Alright, Neal, you're running this, so it's up to you.
Would you rather do a 1v1 or a 2v2?
How
I'm
would
done.
you... Yeah, I guess that the rest of the problems, so the center problem should be the hardest one, right? And then the rest should be...
The diagonals should be the next ones.
No, diagonals? I'm not
I
sure.
think the diagonal should be the next hardest.
But then it's kind of silly, because you do the easy problems first, and
I
the
think
easy
you can
problems
just-
determine what you can
No,
do.
I mean, just pick a chess knight, right? And start from some cell.
I have another... I mean, another thing you do is you put it as a magic square, right?
What does that mean?
No, because they all sum to 15, right? So, like, in terms of difficulty.
So in terms of difficulty,
Yeah.
it's like... Yeah.
Yeah, that's
But no, I think this magic square is what we're describing, where it would... Isn't that right? On a
Yeah,
magic
I think
square,
that's
the
right.
Lines are... Actually, it's maybe not true. Oh, but then the 5 is in the middle, which is a little bit too broken.
Yeah, 5 is... Which is... I don't know. That seems okay.
Okay, I
This
think...
is only if we do a 2v2, though, because otherwise we don't want this many problems.
Yeah, but I think we have enough. I mean, it sounds like you guys are all on board. We should do another 2v2.
All right. So to do another
I can compete in
2v...
this one.
You want to compete?
Actually,
Sure, yeah.
I think that we can stick it out. So, is 1v1 better than 2v2? Is it more fun to watch? I'm not sure about that.
I personally, I like 2v2 a lot, just because I think there's just more stuff going on, right? Like, people overlap more on problems. But...
What do you guys think?
already, it's pretty hard to follow 4 screens anyway, right?
Yeah, that's true. Neal, how was that?
You can follow in 2
Yeah,
screens.
I was
You have
I was doing a lot of like flipping back and forth.
How many problems did you get to talk about, actually?
I talked
You guys
about
get to see
maybe
some
like
of these?
3-ish.
I hope you guys got to see that bottom right 300. It's actually a really nice problem.
We didn't talk about that one. No.
I'll take a look later.
Alright, yeah, Neal, you want to play?
Yeah, I can compete.
What should the teams be?
It sounds like maybe we should do a 1v1.
Sure.
Yeah, maybe Scott versus Andrew.
Maybe where's Andrew? I'm down for that. Neal versus
All right.
Scott.
What?
I'll play against Andrew.
Maybe you should just give us a chance to watch.
Okay. I'll play versus Andrew, yeah.
If Kennedy wants to see
Okay.
this.
Or Neal versus Andrew.
Yeah,
So-
maybe I want to see it, right?
I don't know. After
Alright.
seeing Andy do that 400 pointer,
Yeah, you don't want to play
it's a
against
little
him?
scary, yeah.
Well, my strategy doesn't involve getting the hard problem anyway, so then it kind of works well as a good counterbalance. Yeah, let's do it. I'll play against Andrew.
I'm trying to follow, but there are too many people talking at the same time. Sorry.
All
right,
Are you interested to play another?
I think I can play one more and then get some rest.
Yeah, I mean, if you guys are tired, then, you know, no worries. I mean, you did the goodbye, you did a lot more stuff, so.
Yeah, we didn't even do the goodbye.
Yeah, I mean, if you'd like to play one right now and then go to sleep, that's fine. You know, if you want to go for it, if you want to go against, yeah, maybe you can pick your opponent. Up to you.
You can pick your own. I think we have enough people that we might as well. Let's do one more 2v2, and then if there's still interest, then we can do 1v1s. Because I think, yeah, enough people want to do.
Okay, sure. Let's do it.
Okay.
Okay. So I think there's one more. There's probably like one more 2v2 worth of problems that we can do. Let me pull up the problem. I think we should take harder problems this time, or should we leave the difficulty?
This difficulty was great.
I think it's good.
Yeah, I think difficulty has got like F problems from regular contestants are really hard sometimes.
Yeah, they do tricky to control the screen.
Right. Okay.
I'm down to sit out also.
So then you can do
people want to play.
Okay. Okay. Why don't we do? All right. I think there are 3 contests with pretty similar difficulty, and we'll score it the same way. I will. The problems are a little easier, but that's okay.
That's great.
Okay. That's fine. Yeah.
We're just gonna be careful because this 100, 200, 300, 400. It's the cat's out the bag now with this strategy. So.
All right. I think. Why don't we do 20, 92, 93, 96 CDE?
Sure, that sounds good. You can just make the board and then send it over.
Yeah, I'll make the board again.
So then you and me, Andrew?
Okay, let's do it.
Okay.
All right.
Cool.
Let me make the board really fast.
Yeah, so we'll take a couple minutes and take a quick break, and then we'll come back, and I think we'll be set up to go.
Yep.
Sounds good. Sweet. All right. Stick around. I'll see you in a bit. Hey guys, we're back, and we actually have another guest with us here. We have Kevin.
Sorry, let me turn off.
Yeah, you got some audio. All right. How's it going, Kevin? Can you hear us? Kevin, I'm not getting anything from you.
Kevin? All right, is it Neal?
We'll just come back to that. Anyway, yeah, so we're going to switch things up a little bit. We've got Neal now hopping into the contestants booth. And then we're going to keep the same teams, Gennady and Umnik on that side. And then instead of me, we'll have Neal and Andrew. Let me actually change that real quick. I think it still says my name. Okay, cool. Yeah, so we've got a whole new set of problems. I think that, yeah, I'm pretty sure that none of us have done any of these problems before. So this is going to be a little bit trickier dynamic for me personally, since I'm going to be talking about these problems and have no idea what any of this entails. But hopefully Kevin will, Kevin, you'll be able to help me out with these. Do you know, have you done any of these problems, Kevin?
Kevin?
Sorry, give me... Oh, I have to mute this. Okay. Hey, sorry, what did you say?
Yeah, we can hear you. Yeah, it's cool. Yeah,
What's
do you know
going
if you've seen any of these problems? The ones that we have lined up, 92, 93, and 96.
Let me open them. Yeah, I don't think I've seen any of these problems.
Okay,
They're new to
cool.
me.
So then we'll just both be jumping in fresh, and we'll see how that goes. All right, cool. Are all four of you ready? If so, we're gonna get started in the next minute or two. Get things going.
So which problems are we doing? It's the C through E on these three?
Yep. I'm gonna pull these up as well, so that I know what I'm looking at. All right, so we're gonna start in 30 seconds. And we're gonna have another 2v2. Neal and ecnerwala versus Taurus and Umnik. Press 1 if you like Taurus and Umnik. Press 2 for ecnerwala and Neal. Let's see it. Okay, a little bit of a mix. A little bit of a mix. I think it leans 1 slightly, but I think there's quite a few 2s here. Kevin, how do you feel about these two teams? Press 3 for commentators. Yeah, let's go.
So we have Andrew and Neal. I don't know. I think it could be about even. So Neal's like, I guess more of a newcomer to the scene, but I feel like they could definitely have a chance against Taurus and Umnik.
A newcomer to the scene from like 12 years ago, or a newcomer to these contests in particular?
He came back like maybe a year or 2 ago, I want to say. Is that right?
Something like a year ago. Yeah, I mean, that was really funny too, because I don't think we ever expected Neal to come back after all of this. But yeah, I mean, he's killing it. He just hit LGM. I mean, he's higher rated than both me and you. So, yeah.
Did you get him back?
Huh?
Or were you involved in bringing him back?
Or? I don't think so. I mean, I guess he knew that I was still doing these, and maybe that affected his decision, but it's not like I was the reason that he came back or anything. All right. Let's get started. 10 seconds now. Count it off for us. All right, let's go. And off we go. Let's jump right into the screens and see what people are working on. Gennady got started.
So it looks like Andrew hasn't opened any problem yet. Is that right?
Yeah, I'm not seeing anything. Let me just check with him to make sure we're all good. Hey, we started. I did. I said it in the chat. Oh. Like,
So
can you share your screen, please?
Nick is looking at 96
Right.
or D, sorry,
A little
which
bit of a
is
rocky start, but yeah. Okay, so sure. So Kennedy is
200
going for this
point
100 pointer. He's already coding. Wow.
That's super fast.
Okay, Neal's looking at 93.
So Andrew and Nick are actually looking at the same problem, the problem about static sushi, which is 200 points.
Interesting. So Kennedy and Neal both have different 100s that they're looking at, and then yeah, Andrew and Nick are actually on the same one.
So I guess we can look at the problems.
Yeah, let's take a look at the sushi problem and see what we have. So Kennedy already got this this first 100.
Oh wow, nice.
It seemed like he got that instantly. Like before we could see it, he was already coding and he was already ready. Super fast solve from him. Let's see what he does next. I think that's going to be an interesting question. So I mean, he knows that Nick is working on 96B. Maybe he's going for his own. Yeah, it looks like he's going for his own 200 pointer. So he's going for 93, the 200 pointer.
Yeah, so I guess I can talk a bit about the sushi problem. So there's a counter, which is a circle, and there are some pieces of sushi around the circle, and each of them gives a certain amount of nutrition value when you eat it. But you have to move between the sushis. So if you walk X distance around the circle to get to a sushi, you consume X energy. And your goal is to maximize the total value of your nutrition from the sushi minus the energy. And you're allowed to stop eating the sushi at any point. So you don't have to actually eat all of the sushis or any at all. So it seems like... So if...
Omnic started for sure. It looks like Andrew started as well.
Scanning the inputs. So there's like a straightforward n squared DP, I guess, which is just keeping track of which is like the first sushi on the left you've eaten and which one is the last one you've eaten, because your sushi is always going to be an interval. But it doesn't seem as straightforward to optimize this when n is 10 to the 5 at most.
By the way, Kennedy is looking at 96B. I think it's, or sorry, 93B. I think it's going to be a pretty good problem for him, the 200 pointer on the 93. In fact, it looks like he's already on his way to it. But, oh wow. Okay, he's getting it wrong. But essentially what you have to do is you're given two integers A and B, and you have to print any rectangular grid with black and white squares where there are A components of black squares, connected components, and there are B components of white squares. Yeah, it looks like he's submitting again, so he feels pretty good about it. And then we're seeing Andrew and then switching over to Umnik. Both of them are coding this 96 200-point problem. I think that's going to be an interesting face-off. Honestly, it could determine the whole thing. Neal just got his 100 pointer. We're seeing. Wow, this is actually, yeah. Neal wasn't kidding. This is a lot to look at. 4 screens and everything moving. I think especially at the beginning. Kennedy's actually going for another 200 pointer. So again, same total of points in this round. There's 1,900 points total, which means that 1,000 is the score that you need to win. So if you get 500 points here, I mean, he's going for the 200, right? So if he gets another 200 points, I guess, yeah, I mean, I guess at that point there are just a lot of combinations that he can win with. Yeah, and so again, Andrew here on 96 200 pointer, and Umnik as well on the same problem. It seems like this one is taking both of them a good amount of time. Kevin, do you see how to optimize the quadratic DP?
Yeah, so in the chat, I think Xiaowusi1 said that you just want to change directions once. So like you first move to one end or like you move as far as you can in one direction and eat some of the sushis and then possibly go back and go some distance the other way. And if you just do that and do some like prefix sums, I think you should be able to do it in like O of n or so.
Okay, I see. So you're saying there's a pretty straightforward greedy where you only have to explore a linear number of options? Is that the idea?
Yeah.
I don't think I
you
see
try
it.
candidates for the first end, and then I think it's similar to what is this Umnic screen on the?
Yeah, we're looking at Umnic's screen right now.
It's like it's like kind of like a sliding window where you like try going all the way left k times, or like you go left for x sushis, and then you try you decide what's like the best place to go on the right after you've gone left and come back to the start point. And then once you change x by 1, you just remove one candidate for y.
Mm-hmm. I see.
So
okay, yeah, I mean,
like
he's testing. Is that he's getting the wrong output on the first sample? By the way, I'm gonna add the tasks just in chat so you guys can take a look.
Neal just submitted the last 100 pointer.
Here's the first one.
It seems like he's gonna get it. Yeah, AC.
Okay, wow. Yeah, so I think this is going to be interesting because I think if you come in, like, depending of who of Umnic and Andrew gets this 200 pointer, it is going to make quite a bit of difference here. Kind of funny that, like, both Neal and Tourists have actually gotten 2 problems in the time that Andrew and Umnic have just been working on this one. But, I mean, with how far they are with it now, I definitely think it doesn't make sense to switch. So let's take a look at Andrew and see what he's doing. Andrew has the whole setup where he can see the scoreboard bottom right, and that way he always has that in view. Wow, getting another 200 pointer.
I think that's the right strategy. 200.
Okay, so at this point, essentially, Andrew has to get this 200 pointer that he's working on, I would say, for them to have a good chance, and then they have to solve 2 of these 3 hard problems. Oh, Andrew just submitted.
And I think one of them has to be the 400. If they just solve the 2 300s, it won't be enough. Is that true?
100, 100, 200, and then 2 300s is enough. I think it's just barely 1,000, right?
So any 2 of the hards is enough.
I think that's right. Yeah, any 2 of the hards. I mean, obviously, like from like Gennedy's perspective, he knows all this as well, and so he's coming in, I think, with the same mindset. So, yeah, like, oh wow. So I think Gennedy's actually. Basically, he's looking at all 3 of them, which is a pretty interesting choice, and just trying to kind of like see what's easiest or to set himself up. I think now for Umnic, wow, this is such a close race. Kevin, can you take a look at the times and just make sure? I actually think that yeah, this one is in dispute right now. So Andrew and Umnic actually both solved this problem at almost exactly the same time. So a couple different scenarios. If it turns out that
I think Andrew solved it 3 seconds earlier. 805 and 808.
Okay,
that's
wow.
So.
Because yeah, I mean, if Umnic gets that, then they have 700 points, right? And then any one of these 3 is enough to win it for them. I think that's almost guaranteed. Whereas here, I mean, I think it's pretty much kind of like even ground, with the exception that Kennedy obviously has a bit of a head start looking at these problems. But I think any 2 of these problems for either red team or blue team, and that's the game. So let's take a look at which ones they're looking at. Okay, so we have Andrew on 96. We've got Kennedy looking at 92, but I know he was looking at a few other ones before. And then
Neal's also flipping through multiple problems.
Neal's also looking through multiple. Looks like 92 and 96. I mean, Neal and Andrew shouldn't be working on the same problem, obviously, so I'm a little bit confused.
I think we could see some working together, maybe.
Umnic is on 96. Yeah, working together I think makes sense, but like with how it is now, like definitely if you get down to like 1 problem, right?
Yeah, in
you
the last
absolutely
problem.
should work together. I think it's kind of interesting. Yeah, like we didn't really get to see that dynamic in the last round because Andrew and I both solved our last problem like almost exactly at the same time. But yeah, kind of like if someone else comes in and now they're just trying to help however they can. So yeah, Umnik at least seems pretty focused on 96. Neal now looking at 92, and then I think Gennady is actually already coding for 92. Yeah. It's kind of funny that out of all these 4, no one is looking at 93. I guess maybe that's just chance that it turned out that way, or maybe they just, from the look of the problem, it doesn't seem like a problem that's solvable very quickly.
It's called bichrome spanning tree. Sounds kind of scary to me.
It sounds quite scary, yeah. Cool. Yeah, so I think Gennady right now is going to be the only one coding. We're going to see a little bit of downtime for the other 3 while they think about these problems and see what headway they can make.
So I actually have a question for you, Scott.
Yeah.
When you played with Andrew, did you guys like talk about the solutions to the problems at all, or were you just mostly working by yourself?
Not at all. I mean, so we've played before this stream, right? That's a good question, by the way. Like we've had rounds before, definitely, where we had to solve the problem together to make it. Andrew is ecnerwala, by the way. Someone just asked. In 2v2, and it's like it came down to the last problem or the last 2 or 3 problems, and we had to talk about them to solve them together. Yeah, I mean, the one just now, I think, is essentially like we said, all right, I'm going to do the 100 and 300. Andrew is going to do the 200 and the 400 specifically. Like we picked out those problems without knowing anything about what they were about, right? We got pretty lucky, I think, with the problem types, and just like they both of the hard problems fit our style pretty well. Yeah, and I think it just worked out. I mean, kind of like I think a natural, next question after yours is like, what if we do 2 contestants but you have only 1 computer, right? And I'm not sure, honestly.
Yeah, Gendy's just submitting the 92E.
Mm-hmm. He's getting wrong answer. Pretty interesting spot. And then I believe Neal is the other one. Yeah, Neal's also working on 92. Still looking at the screen right now. Andrew's actually gotten started coding 96.
Oh. So 96 looks like it looks like a counting problem, I guess. We're trying to order different types of ramen, and we're trying to decide how many combinations we can order.
Sounds like my kind of problem. Do you know what the specifics are? Exactly it works?
Yeah, so there are n toppings, and there are 2 to the n types of ramen, one with or without each topping. And Akaki is trying to order multiple bowls of ramen, and so each of the bowls of ramens have to have a different set of toppings, and each of the n toppings must be on at least 2 of the bowls. So there has to be at least 3 bowls total, and there could be you could order all 2 to the n bowls. So we're basically trying to count subsets of all the toppings.
Oh, I see. Interesting. What is the limit on n?
N is 3,000, so we're looking at probably a quadratic time DP, and we're of course trying to compute it in modern prime.
Cool. Yeah, I think this is an interesting spot for us because I think we're coming in without too much time to think about the problems ourselves. But yeah, that's.
Yeah, it doesn't seem that straightforward because there's not an obvious way to do like a DP on, given that you have to make 2 to the n choices already.
Yeah, and by the way, I mean we said Andrew was coding before. It looks like it was essentially just like the basic input, so probably more just setting up, and I think he still has some thinking to do. Just looking at the screen right now. Let's go to Umnik as well. I don't think Umnik has done anything for this problem yet either. So, yeah, does seem like a tough one. At what point do you think it makes sense? And by the way, this is the 400, so I think that's understandable. But at what point do you think it might make sense to switch problems for any of these 4?
Well, I think did you assign the point values, Scott? or?
I think Andrew did. I mean, it's just based on their difficulties. So
Okay.
I know Kenku has a rating, and I think that's probably what he used.
I mean, I feel like each team should have at least one person look at each problem because they're all worth the same at this point.
Mm-hmm.
But I'm not sure which. I feel like the person who is working on the 96E would be the one to check out 93E because 92E seems to be the easier one at this point.
Yeah. I mean, we know that Kennedy already submitted and got wrong. So whether he's optimizing that, let's come back and take a look at his screen. Kennedy has a lot of these zzsol.cpp or zzsol.cpp. Kennedy's editor also is very unique. I'm not sure I've seen anything that looks quite like this.
Yeah, so we have Andrew who uses Vim, and then Umnik.
Yeah.
He uses. Does he also use Vim?
I'm not sure.
Or does he use Sublime Text? It was in the right terminal. And then Neal is using Sublime Text, and Kennedy is using the blue thing, which I think is called Far Manager.
Far Manager.
But
okay. I
don't know too much.
It's essentially just the same as like a Vim or.
Yeah, it looks pretty similar to Vim.
Yeah.
Or yeah. So he has a function called. I guess he's just like making changes right now. Do you think he has the full solution, or?
Well, to be honest, I mean, I don't think that Kennedy would. This is maybe my second or third time saying this today, but I don't think that Kennedy would have it unless, like, would start typing unless he thinks he has the solution. Like, I don't think he's usually the type to like start from the code and make that into the solution. Like, I think he's usually the type to like figure out the problem, understand what he needs to build, and then build it. I mean, it's possible that his first submission just had some like logical errors, and so now he's coding whatever he needs to code to fix it. And you can see him like flickering back and forth to check the scoreboard and see that nothing's changed. I think Andrew's setup is pretty nice where he has that in his bottom right.
It looks like Andrew has actually started coding for the ramen problem. It's very short. He's just printing out the answer, just like.
There's no way. Is that all it is?
I guess maybe once you work on it on paper, it's just some like powers of 2. I don't know. So PP2 looks like 2 to the 2 to the n.
Okay, still has some logic here. He's doing something based on the parity of the sign too.
I guess this is one of the problems where you'd mostly want to work it out on paper and then like write a pretty short program, so you probably won't be able to understand what's going on here.
Yeah, I know he ran this first step when he got 14 instead of 2, I believe. So seems like there's still something to figure out here. Let's see what Umnik is doing, because he's should be working on the same problem here. I think he's still thinking. Honestly, I mean, that strategy almost paid out for Umnik last time, to just think through it and like make sure he had it down before coding. Whereas, yeah, like just to make sure that kind of there's nothing wrong there in the 1v1 with Tourist, but still thinking through it, it seems like. So yeah, you see he has 14 here as his output. Andrew does. So I'm wondering what's going on. Let's check back in with Neal. I think he's. I love that. This is just a little bit, but I love that Neal actually hovers over and like selects the text instead of clicking the copy button, which is right there. But I mean, he's going through the samples. I think this means that he has it. So it's going to be a funny spot, by the way, if each team gets one of these 2 problems. and like they solve them pretty close together, because at that point then
everyone's just gonna be racing
all
on
four of
the
these people are gonna just be pushing on problem E. Yeah. All right, so Gennady came in and solved E, sorry, 92E specifically, and so I think for him 93 is like a pretty clear next problem. We'll see how soon Neal realizes. I mean, Andrew should tell him, because Andrew should see it, I feel, but maybe he's not focused on that either. That's gonna be honestly. I mean, I think as we keep up with this, I think there's a lot of questions here of where we can go next with this tournament format. I think one thing obviously is building up more of the infrastructure, even to have something automated which checks when you've solved the problem, to give like push notifications or to play some kind of sound when somebody else solves a problem, things like that. I know that there's resources right now to find like problems that some group of people all has not worked on, so using that as well. And people had some pretty good comments with the stream too, saying like it'd be cool to show multiple screens at once. So that's something we should look into as well for sure. So yeah, a lot to come. Anything else that you guys in the chat would want to see from another edition of this? I think okay, so Neal now realized, and so he's gonna switch over. Yeah, so Andrew has to get this 96, and then Neal has to get 93 afterwards. They have to get both problems. Right now, blue team is at 400, red team is at 800. Essentially, red team can win with either of these two problems, and blue team needs both.
What do you think the strategy for the blue team is? Do you think they should work on the same problem or two different problems?
I think different problems is probably the way to go. Like, I think they just have to bet that they'll be faster in both cases, right? Because I think one thing is like, I fully expect Omnic and Gennady in this spot to be working on different problems, right? There's no sense working on the same problem because they can just give themselves two chances to win. So given that they're both working on different problems, you kind of have to beat them on both of them. So it's a little bit of a lopsided situation, which is kind of funny, but I think it makes sense for both teams to work on both of the two problems.
But on the other hand, if I'm Taurus and Omnic, and I saw that, I guess I don't know which of the other people are working on which problem, but if I saw the ramen problem, I might guess that Andrew was working on it, and then if I felt strongly that Andrew would work on it, then I would maybe send both people to work on 93E. I don't know.
That's interesting.
It's kind of a
yeah. Well, the other thing too is like they don't even know, for example, like which problems are Andrew and Neal working on at all, right? Like it's possible that Andrew and Neal were just working on 93 and 96 all along, that neither of them tried to do 92, right? In which case they are in a time crunch and they really need to get something going, right? Or obviously it's possible that they were working on 92 and 93, or like in this case it was 92 and 96, right? But you know, if you know that they got sniped on one of the problems, then in theory, yeah, you should try to focus on the problem that they have to start fresh on instead of the problem that they've already been working on for the past 5-10 minutes. Changing the weights on the 400 problem. So somebody, just had a suggestion that we could change the weights on the problems just to kind of, the 400 pointer, at least in the one that we did, it didn't seem like it came up. I think there are sets of problems that you can have where it makes sense. I mean, obvious ones like ACD is one, or just problem D and problem E. But I think that's a good point for sure. I think there's more we can do with the problems there. Implement a 1v1 contest on code forces. I mean, that's the dream, right? I think there's if you think through that idea, there's so much there, honestly. Like, even if it's just like, you could queue and play, and you can have your ratings and then get problems. I mean, for the time being, obviously, it's like we're working off of old problems, right? So, these are unofficial rounds, but I do kind of, I think there's a lot there in the future, potentially, like, if we do, and by the way, next time, Kevin, we do one of these streams, we should run a bracket, like, we could run just like a, kind of similar to the one that we ran in the past, but like, like 4-person, 6-person, 8-person bracket, something that would like finish up in a reasonable amount of time, but we could get to see the progression there. Because I think that's super excited, and there's a lot there. But yeah, imagine if you could go into Code Forces like, whenever you want and just queue for a match. And then it's just there for 5 problems that neither of you two have done. I honestly, I think that could turn all of this upside down. Yeah, so back to this. I mean, Kennedy working on 93E. Pretty expected there, I would say. It looks like he's already... Oh no, he's starting fresh here, so he's getting a new file. Neal, same thing. I think as soon as he saw 92 was taken, 93 was clearly the next bet to go. Andrew's here learning on Wikipedia about Stirling numbers of the second kind.
You gotta brush up on that.
Yeah. I imagine he has something in particular that he's looking for. I wonder why he has this mod 2 thing.
Oh, it actually looks like I've submitted on this problem before. On the 96E, and I have like 10 wrong answers and TLEs, and I haven't solved it.
You haven't solved it. Were these submissions from like a year ago or what?
Yeah, they're from April 2018. So I just never end up solving this problem, I guess. So.
Do you know in contest here? Let's take a look. I'm actually curious to see like how long did it take people to solve the problem in contest. And I feel like also Andrew said this would be easier. I don't think this is easier at all. But okay, wow, Dreamoon got this in contest in half an hour.
In like half an hour. So that's pretty hard.
0119 also about half an hour, but 14 solves total. Most people took quite a bit longer than that. So 300
Oh
IQ,
wait, sorry. The problem I was looking at was F. Sorry.
So 300 IQ
like
looks like he took a few
had
minutes.
2 very difficult problems.
Yeah. Yeah. Meanwhile, the other problem, 93E, kind of similar, honestly. The fastest solves were on the order of 20-30 minutes. So definitely this one is a little bit easier than 93 than 96. But yeah, both problems seem to be pretty tricky. We'll see how this turns out. Suggestion: 1 problem has hidden score difficulty disclosed only after it is solved.
Ooh.
That's pretty interesting. Yeah, that adds a lot of like it makes the strategy a lot more ambiguous for sure. Yeah, and I think there's things to play around with there. I also think yeah, like we should definitely try some more contests out where each problem is worth the same. Like it's just the number of problems. 5 problems, you try to solve as many as you can. Or
is it still with problems of like different difficulties or more uniform difficulties?
You can, yeah, I mean, probably nothing should be like too out there on either side, but like you can definitely still have variance in the difficulty. Like I think there's kind of obviously like it's an interesting question to be able to determine which problem should be the next problem to work on quickly, and then yeah, I mean you have these scramble situations too where both contestants are working on the same problem. So I could see that there. I know Kennedy is a big fan of having them all be equal weight, so we should try some of those out for sure. We should have a period of time when participants should read all the problems. So like you can't code until a certain time. I mean I think probably like the practical implementation of that idea would be like 2 people and you have only 1 computer, right? Because then the other person, like while someone's coding, the other person essentially just has to read and think through the problems. I think that could be really cool for sure. I think that could set up for a lot of strategy. This is a submission, by the way, that we're seeing from Umnik. So
oh wow,
it's possible that they could just take this outright if this turns out to be correct. So let's see.
Oh, 6 cases.
6 cases, yeah, we're rolling.
Wow, this is looking pretty. It's looking like it's gonna be the end.
You can't think before the end of the period. That's gonna be a tough one then for us.
You can't think.
All right, I think this is looking like it.
I think this is gonna be it.
Nick fail some freak case at the end.
N equals 1.
All right, he got it. Wow. So that's that. Torres and Nick take this match. Honestly, yeah. I mean, I think Andrew was quite close, and I don't know where Kennedy and Neal were with this 93, but well played. So Nick and Torres finished with, I believe, 1,200 points. ecnerwala and Neal finished with 400. Just the score count makes it sound a lot more lopsided than it actually was. Like I think even coming into these last couple problems, it was very doable.
Gendy is still coding the 93E.
He's trying to make a statement. I mean, he has to know that his teammate is finished, right?
What is that? Going for the 1,500 points?
1,500, yeah.
1,500 to 400. Does Andrew know?
Can we ask the four coders how to come up? Yeah. So we'll have all four on the call afterwards. So you guys will get to ask them any questions that you have. He has all his warnings on the compile, but he just goes right through them. Let's see.
Are you close? No, not really. Hey.
Hey. How was it?
Damn. I'm really bad at counting.
Yeah, we saw you were looking at the Wikipedia page for Sterling numbers, but we weren't too sure what exactly was going on there. But like, what did you have in mind? Were you close?
I have like an n cubed or something. Like I can count it, but
Hey.
not that close.
Nice job, guys.
Yeah, tough break.
What we did kind of didn't make sense because I was so I did those 200s, right?
Yeah.
And then Andrew had that 200. And
Yeah.
so what I was hoping for was 300, 300.
Okay.
But then Andrew, it turns out he like looked at the 400 and he's like, oh, I think I know how to do this. So he went for that. So in that sense, like, I shouldn't have done that extra 100.
I didn't actually get to 400. That was, sorry?
Oh yeah. Do you think so? Yeah, I mean, it looks like you were close on the 92E to 300.
Yeah, I think I knew what to do. I just I was like 2 minutes away from finishing it.
Yeah, so
I
maybe
had
that
the
made a difference.
I had the like max value, but you have to reconstruct it too, so you have to do a little bit of work here.
Yeah, it's pretty interesting. It seems like in this format with like 300s, 3 200s, 2 300, and a 400, the like 100, 200, 300, 400 strategy is quite good. I mean, you have to solve some of the hardest problems to make it work, but yeah, I see what you're saying for sure. Yeah. Did you guys get sniped in some of these problems, or were there any of these?
Just that one.
Okay.
That was really important.
Yeah. Super important. For sure. Yeah. Yeah, because at that point, the thing was funny because both of the U2 teams at the end, when it came down to those three problems, either of you could have gone 2 and 1, right? But you were both looking at 92 and 96. Neither of you were looking at 93.
Oh, really?
Yeah. And I mean, honestly, 93 did seem like a pretty nasty problem, but
yeah, I think I know what to do now. But there's a few cases you have to build the NST, you have to take max along the path, do a bunch of work. It'll just take time,
Yeah, makes sense. Andrew's reading up on the editorial. I'm like, how's it going? How are you feeling? It's pretty clutch solve at the end.
Yeah, a bit tired. This is the first contest for me today.
Yeah, you must be exhausted.
Do you see this? This is a very similar concept to Sterling numbers of the second kind, Wikipedia.
So you're on the right page. Yeah, no, Andrew, we saw him on the Wikipedia page looking at this, and we were like, I wonder what he's looking into. Yeah, that's cool. Nick, how did you solve the 400?
The second of each tutorial that I saw, like inclusion, exclusion, and some real numbers. So I guess inclusion, exclusion is obvious when you see the problem. You should do something along the lines. It's probably not hard to come up with some polynomial solution. there are even some points for like n up to 50, I think. But there are some bottlenecks, like where it's hard to avoid cubic time.
Yeah.
Yeah. By the end of the contest, I was stuck on a few cubic time solutions.
There is a smart idea. Basically, you have to calculate the number of ways to like. You should choose in what bits there will be no more than one used, but there are some bits where there will be zero, and it's hard to combine them, not in cubic time, but like, the cute idea is that like, to calculate the number of subdivisions you can calculate in them without zeros. It's just still numbers. And to include zeros, you can say that we will have one more group, and every group can be zeros. So after you have calculated zero numbers, you can do it in constant time. Just combine two values.
That makes sense. That's pretty cute.
Yeah. So that was like the last cubic thing in my solution. And, I even thought that like I have solution. I started to write it, and then I understood that I have the cubic bug, and I have to think through it. But then,
yeah. Makes sense.
Kennedy, how's it going? How are you feeling? I saw you were showing some of your video earlier.
All good. Glad you won.
Yeah, it was a pretty good snipe on the end. 92E, I think Neal was pretty close, and that could have mattered for sure.
Yeah, that was.
It was close on 92E. Okay.
Yeah, like maybe like 2 minutes away.
Just lucky.
Cool.
What was the
if you guys
difference
have any
on
questions for any of us, please feel free.
So what was the time difference on the 96?
It was 3 seconds. It was very, very, very close.
96D?
That was 96D. Yeah, you guys were 3 seconds ahead.
Oh, Andrew got that.
Oh, we actually were ahead.
Yeah, so
Hell
that was crazy. After that one, I thought like you guys had a really great shot.
Oh, nice.
Because,
yeah, I mean, after that we realized that like we just needed two of any
team.
The winner, all three, any last three problems would win for either team.
I think it was kind of funny because so Neal, you were working on these two 100s, and then Taurus was working on this like 100 and these 200s, and then this one 296D. Both of you two, Andrew and Umnik, like both of you started at the very beginning. And yeah, that was the last of those 6 problems to be solved. So I think it's pretty interesting. I guess in retrospect, maybe it should have been worth some more points. But yeah, no, that was a big moment for sure.
Yeah. So if it was 3 seconds in the other way, then we needed just one of the last 3.
You needed one of those last 3. Yeah, obviously.
Yeah, it would have been easy.
That's probably not possible for us to.
Yeah. Yeah, I mean, you have to like happen to pick the same 2 problems as them, and then snipe both of them, and then get the last problem.
Yeah.
I think. Also, it's like you have some mixed strategies where like the other team can just look at all 3 problems, and just like think about all the 3 problems and get to a good idea, and then as soon as the team that's behind gets their problem, then you know to go work on the other ones. Things like that. So it does get pretty. I think
actually that's really interesting.
Yeah. It gets really tough. Yeah, if you have to get all 3 of these problems to win these hard problems, then yeah, it's a really tough spot. Cool. All right, yeah, I think we're gonna wrap it up pretty soon here with the stream. But chat, do you guys have any questions for any of us while we're here?
Yeah, sure. Let us know what you think.
Yeah, we'd love to hear any feedback. I know people had some pretty interesting different ideas, like hidden problem values. Yeah. I mean, we talked about even building this out on code forces, which I think would be really exciting.
Sure. Be sure to leave comments at Code Forces.
Yeah, like, comment, and subscribe. yeah, anything else here? Otherwise, I think we're gonna wrap it up here. But stay tuned for more. It would be good for Torch to lose sometimes. Well, I got some great news for you. Cool. All right, I think we're gonna call it with this. Thanks everybody for watching. We actually peaked at 1,200, 1,300 viewers, which was pretty crazy. So, cool. All right, expect to see more of this pretty soon. We'll put up a recap post on Code Forces afterwards. And yeah, we'd love to hear any more feedback. I think also building out some of the infrastructure for these contests would be super good as well. So, cool. Thanks everybody.
Thanks everyone.
Thank you. Bye.
Great, bye.
Stop the stream.
Take care, guys.